Welcome again. This is the last class for this Min-StarkNet Build. But then also we'll have a StarkNet Nairobi bootcamp with a hackathon like next month, right? So if you have a friend from Kenya, probably Nairobi, or maybe Africa or something, person can join in, register, because there will be prizes at the end of the classes and all. So I will still repost the link in the group by tomorrow or so. So Darlington, probably just take it up from here.
Yeah, thanks. All right. Good evening, everyone. Happy Sunday. Well, it's great having everyone here once again. Okay, so I'll just be sharing my screen and we'll be kicking off. All right. Paul, can you make me co-host?
Yeah, I've done that. I think just take okay. Okay, yeah.
All right, okay. So yeah, welcome again, everyone. Well, we're just simply going to be kicking off from where we stopped last. So we're going to be kicking off from last place we stopped. So basically the whole we stopped at in the last class, right? We got to build an NFT application and an NFT marketplace. So today we are going to be building an EMM. Well, we don't have so much time, so we're skipping the ICO and the staking contracts. They are simple contracts you could probably check out, and yeah, they are definitely self-explainable. Well, but we will be looking at how to build and deploy an EMM contract today. We'll be looking at how messaging bridges basically work on StarkNet generally, how to build one, and yeah, deploy on StarkNet too. Lastly, we'll be looking at upgradability, how to upgrade your contracts, how to build upgradable contracts in Cairo. So, yeah, so, okay. Yeah, so without further, let's just get started with the first thing, that's the automated market maker contract. So we're just going to head into the source folder, right? And heading into the main EMM controller and into EMM.Cairo. From here, we can see the EMM contract. So we are going to be building out this contract, and along the way, we are going to try to understand how it works. So as always, we are going to first try to understand the logic. So I'm just going to put this side by side. Yep. All right. Let me make this a little bit smaller. This a little bit. Yeah. So as always, we're just going to first try to understand the logic. What does the contract do? And then we're going to try writing it out ourselves. So let me move this. Okay. So I'm going to start from creating heading over to the main EMM. So inside there, you can find the interface of the contract. Like I said, this might not be enough to probably understand what the contract does. So we're just going to head over and create a new file. This new file we're going to call emm.cairo. emm.cairo. All right. So before we go ahead to start writing the Cairo logic, right, I'm just going to close this down. Okay. No, I'm just going to open this, right. So before we go ahead to start writing our contracts, right, let's try to understand what exactly this contract does. So basically we have some imports, we have certain imports that we have to import. Then going down, we can see we have to set some constants, like some different constants. As you can see, we had to set the balance upper bound, right? We have set the balance upper bound. So the balance upper bound basically defines the maximum amount of each token that should belong to the MMM. Generally, like the maximum amount of token that can exist in our automated market contract, because we want to make it automated market maker contract, right? We want to make it as simplified as possible. Secondly, we're going to have two constants to represent two different token types. So we're going to have token type A, and we are going to have token type B. All right. So you know how a real automated market maker works, right? Something like Uniswap. On Uniswap, SushiSwap, and the rest, right? You get to add tokens by adding their wallet address. A lot of tokens can exist in the pools, probably create a pair with Ethereum or any other token with much liquidity, right? So, but in this our contract, we want things to be very simple. So we're just going to keep the pair between two different types of token, which we define as token type A and token type B. Next, we are going to set a pool upper bound. So the pool upper bound, we're going to set the pool upper bound. Now, the pool upper bound defines the maximum number of tokens that can exist in our pools balance, right? And lastly, we are going to define the account balance bound, right? The account balance bound. So the account balance bound basically defines the maximum amount of tokens that a user's account can have that can be held by a wallet address interacting with our contracts. All right. So then we go ahead about to create some certain storage variables. We're about to create some certain storage variables. I'm very sorry about the background noise. Okay, so we start with our first storage variable, which is an account balance. So this particular, let us call this storage variables. All right, storage variable. Okay. The storage variables, first storage variable, we have the account balance storage variable maps the basically maps an account address. So we represent this, the token type to the balance. So basically the idea behind this is that if you want to get the balance of a particular token, simply pass in the account address and the token that you want to get its balance, and the balance to be returned. So this storage variable is what holds the storage for like different account balances and token. Secondly, we have another storage variable, right? The pool balance. So the pool balance storage variable, right? Is a mapping of token to balance. So basically supply the token and you return the balance that token has in this pool. Then we head over to create some getter functions. We head over to create some view functions. So under getters, the first getter function we got to create, right? So it's the get account token balance. The get account token balance. The get account token balance. So basically what this particular function does is it queries for the account balance of a particular address for a particular token, right? And returns it. So basically you just call the account balance .read, passing the account ID and the token type, and then return the variable as the token balance for that particular account. And we also have another getter function that's the get pool token balance, right? The get pool token balance. So this particular getter function simply returns the token balance for a particular pool and tokens pool. So if you need to know how much, you just call this function and it returns the number of tokens held in the pool. Then we head over to create some external functions. So the first external function we created was the set pool token balance, right? So basically what this function does is it first of all it implements a check, right, to ensure that the balance that we want to use for our pool does not exceed the maximum allowed tokens as our balance upper bound is set earlier. So once we check that, so let's just put that, let's say check for balance upper bound, right? Let's just check for balance upper bound. So once we check that it doesn't exceed the balance upper bound. And the whole logic here is we do not want it to get to the balance upper bound. So we use the -1. So in case our balance upper bound was 100, we want to make sure that it is less than or equal to 99. That is 100 minus 1, 99. So we know that this particular method, right, checks that this balance is less than or equal to the balance upper bound. But we don't want it to be equal to the balance upper bound. So we have to subtract by 1. So if this is 100, like I said earlier, we are checking that the balance is less than or equal to 99. Then we update the pool balance. Next up, we are going to move over to the next external function, which requires us adding a demo token. So we're going to call this function add demo token. Right? So the add demo token function basically, when it is called, right, it just modifies the account balance for that particular token that was added. So the whole idea of add demo token is this is a simple application, and if we want to test it or play around with it, we need to have a means to like add demo tokens for both our token A and token B, right, in order to be able to play around with the EMM contract. So using the external function, we can simply just add demo token for both token A and token B, right? So, but I told you, I think in the introduction, right, I said in the EMM contract, to learn how to like dissect logics, right? So most times you don't want to put all the logic inside the function body, as it might clutter make your codes look cluttered, right? A good way to do this is like to abstract the logics behind internal functions. So basically, internal functions in Cairo are functions that do not have any decorator attached to it. So those functions particularly, Cairo interprets, the compiler interprets as internal function. So as you can see here, we are delegating we delegate our logic, right, to the modify account balance internal function, right? And we haven't created this yet, but we're going to delegate our logic to this particular function. And the modify account balance function will probably write out the interface since it's an internal function. When generating our contract interface, the internal functions are not represented, right? So we are just probably going to manually add our internal function. Okay, we're not going to add it here, we're just going to list it here. The interface basically for our internal functions. So having completed the add demo token, we are going to move over to the init pool, right? So we have the init pool external function. Now this in a new pool, right, in our EMM. So basically what it does is, first of all, we are going to check that we're going to check for pool upper bound, right? So we're going to check that it doesn't exceed our pool upper bound. We're going to check it for both tokens. We're going to check it for both tokens, right? Yeah. And And once we do that, right, next thing we are going to do is we are going to then set the pool token balance. So that too is an internal function. As you can, when you come down here, you'll see some of those internal functions, right? So it's an internal function, or have we specified that earlier? Is that okay? That's an external function. The set pool token balance was actually the first external function we specified. So we're just going to like once we do that, right, we're just simply going to set the pool balance using the set pool token balance. We're just simply going to set the pool balance. That's under initializing pool. So first of all, we check for the pool upper bounds, and then we move ahead to set the pool token balance. Then once we are done with that, I think the last external function we have here, the last external function we have here is the swap function. All right, is last external function we have here is the swap function. So the swap function basically what it does is the first thing we are going to do. The swap function is what like it's supposed to actually carry the swap logic, right? But even this we are going to have to delegate it to. I'm going to still delegate the logic to an internal function. So the first thing we are going to do is we are going to first verify that the token from into the pool belongs to at least one of the pool, that is either a token A or a token B. We do not want someone trying to swap pools that, as in swap a token that we do not have liquidity for. So we are going to first check that token is allowed. We're just going to say check that token is allowed in pool, right? So check token is allowed in pool. Once we have checked that the token is allowed in the pool, right? The next thing we are going to do is we're going to check that the request amount from is valid, that it doesn't exceed our balance upper bound. So we are going to check that the amount from is valid, or let's say it doesn't exceed. I'm going to check amount from doesn't exceed balance upper bound. I'm going to check that it doesn't exceed our balance upper bound. Let's put this here. Check amount doesn't amount from doesn't exceed our balance upper bound. Once we have done that, all right, the next thing we're going to do is we are going to check that the user has enough funds to swap. So the user basically has to swap what he has. He cannot swap what he doesn't have. So we're simply going to check, that the user has enough funds. Let's check that user has enough funds. All right, so once we check that the user, that's the particular account that wants to swap, right, has enough funds, I think the last thing we need to do is we're going to call an internal function for getting the opposite token. So like I told you earlier, for this particular contract, right, we have just two tokens we are actually using for the AMM. Since it's a very simple implementation, we just have two tokens, that's an a token A and a token B, right? So it just automatically means it makes our logic simpler to implement, right? Because we know that if if the token user want to swap from the token from A, right, we automatically know that the token to return to the user is token type B. And if the token from is token type B, right, we know that the token want to return to the user is token type A. So we are simply going to we're going to simply call an internal function. We're going to call the internal function get opposite token, right? I'm going to just call the internal function get opposite token to get the opposite token, and finally we are going to then call the do swap function. So the do swap function, like I said earlier, is the internal function that implements the logic, the swap logic, right? So this is what implements the swap logic. So we're just going to call the do swap function. And the do swap function returns the amount. So that's the amount we are swapping, like the amount we're going to be receiving. That's the amount to write. So we are just simply, we're going to save that in a variable, and then we are going to return, the amount to, Now, having done all these right, we now will go ahead to implement our internal functions. So these internal functions hold very important logics for some of the external functions we have here. Those, yeah, for this, right? Yeah. So we are going to come over to the first internal function, right? That's the modifier account balance. This is the first internal function. Now, like I said earlier, the interface doesn't exist here. So I'm just going to like say create it. Okay. So the first function we have, our internal function we have is the modify account balance, right? The modify account balance. This function basically takes in the account ID. The account ID is more like the wallet address in this case, the token type, takes in the token type and the amount, right? Takes in the token type and the amount. And basically what it does is it gets the account balance, it checks that. So it gets the account balance, increases it, calculates the new balance. Once it calculates the new balance, it checks that the new balance does not exceed our balance upper bound before it updates the balance, like using the storage account balance, that's right. So basically, the first thing, okay, like I said earlier, we're just going to put these things. Okay, the first thing we do, right, is just to increase, calculate new. Let's call this calculate new balance. We're going to calculate the new balance. Then we're going to check it doesn't exceed the balance upper bound, right? Balance upper bound. We're going to check it doesn't exceed balance upper bound. Then we're going to update the storage. We're going to update storage. So having done that, that is for the modifying account balance, right? So the next internal function we have here, right, is the do swap function. So, but before the do swap function, I want us to implement the get opposite token function. So we're just going to call this get opposite token function. So that's simpler. And as you can see, it takes in just a token type. It takes in just the token type, right? So, but it does some. It takes in the token type, then it returns the opposite token type. So just simply going to use an if else to do that. Then returns the opposite token type. All right. So the last internal function we have here is the do swap function. That's this function here. So this function, particularly the do swap function, it takes in the account ID, right? Takes in an account ID. It takes in a token from. It takes in a token to, and it takes in an amount from. So basically, you are supplying to the do swap function. We need the wallet address of the user carrying out the swap, right? Then you are going to be supplying the token from. The token from is the token want to swap from. The token to is the token want to swap to, and the amount from is like the amount that we want to swap, right? So once we do that, basically what we want to do is once we have applied all this, right, what we want to do is want to get that's the pool token balance. We want to get pool token balance for both tokens, right? To get pool, we're going to just get pool token balance for both tokens. We're going to get pool token balance for both tokens. Then we are going to calculate. We're going to calculate the amount to, right? That's the amount the user should receive from the swap. We're going to then once we've calculated the amount, we're going to modify the token from, let's call this token from account balances. Yep. We're going to modify the let me just call this modified from account balances. So because we're going to modify it for both the pool, because we're going to modify for both the pool and the account. Then finally, we are going to also be modifying the two balances, right? We're going to be modifying two balances. When I say from account balance, I mean the from is like, let's say the from was token A and the two is token B, right? Once modify the token B balances for both, let's remove this, the from balances. So once modify the from balances as for both, let's say token A balances for both the accounts and the pool. I want to also modify the two balances, that's token B balances for both the accounts and the pool. And once we do that, we'll just simply return like the number of tokens that the user initially received. I just simply going to return that. And I think we already have that explains the AMM contract. If you don't understand that, well, if you don't understand what we just wrote now, you probably understand when we start writing the codes. If you don't understand when we're writing the codes, you'll get to understand it more when we are testing our contracts, right? We deploy and we try to interact with it. So having done all that, we're just simply going to just increase this and let's open this to the side. Let's split this right. Sorry. Yep. Having splitted this right, we're just simply going to start. Yeah. So the first thing we're going to start with, right, is we're going to put out our language directive. After putting out our language directive, we'll start importing some certain libraries of using, right? So from starkway.cairo.common .cairo built-ins. From this, we're going to be importing the hash built-in. Then we will probably also need from Starkway Cairo, so I think .common .smart. From this, we are going to be importing the assets less or equal to the assets non-negative less than equal to. And from we're going to also be needing some system calls, right? So we're going to import this from starkway.starknet.common.syscalls. We're just simply going to import the get call address. I think that's all we need, the get call address. Yep. So having done that, the first thing we need to do, like we said earlier, we're going to start by defining our constants. So let's call these guys constants. I'm going to start by defining them. So the first constant we have is the balance upper bound, right? So the balance upper bound, we're going to put that as 2 raised to power 64. We're going to put that as 2 raised to power 64. Then I'm just give this here, make this look better. And we're going to set our pool balance, right? Constant pool upper bound. Our pool upper bound, we're going to set that to 2 raised power, sorry. I'm going to set that to 2 raised power 32. Next up, we're going to set, let's just set all our bounds. Let's set account balance bound. And this, I want this to be way more smaller than the pool upper bound. So we are going to calculate this. We are going to say we want this to be like 2 raised power 32. Then whatever is the answer, I want to divide it by 1000. So I'll just open my calculator and let's calculate what that will be. This will be up there. So my calculator, and this is, yeah, so we're simply going to say 2 raised to power 32 All right. Okay. And we are going to divide this by 1,000. And this is going to give us 4294967. Okay. So we're just simply going to use that instead. Sorry. I don't think that's what I used to do. I used 2 raised power 30. Okay. Okay, let's just copy this instead. And let's change this to 2 raised power 30. Let's copy so that, yeah, let's just do this instead. All right, so we are also going to be setting, yeah, okay. So we are also going to be setting the token types, right? Token type, you're just simply going to set it as one. You can put the wallet address there, though. Then we are going to set the token type B also. We're going to set token type B as 2. You can also put the wallet address there if you need, but that's not necessary for this implementation. So we're just going to create storage variables next. So I'm going to head over and create our storage variable implementations. Then we're just going to create the storage variable implementations. Okay. Yeah, sorry about that, though. That's my post. All right, so we're going to create our storage variable. The first storage variable we are going to be creating is the account balance storage variable. And we're just simply going to use the storage variable decorator, right? Then create the account balance. Yep. And the account balance is takes account ID. All right, so this account ID is confusing. Let's use address instead. That's easier to understand. So we're just going to say address, and we're going to see token. I'm just going to call this token type. This is also going to be type field. And when we call that, once we return the balance. All right, once we return the balance, that's for the account balance. Next up, we are going to do same thing for the pool balance. So we're going to say the pool balance. Yep. And the pool balance, basically, we want to supply the token type. And we want to get back the balance. Yeah. So next up, we're going to go in, start implementing our getter functions, right? Our view functions. I'm just going to call these getters. And the first getter function we have here, I'm just going to still use it now to bring out signature, and I'm going to check one is the get account balance. Let's check the interface. Basically, it takes the account ID or address. Let's call this address instead. The address takes in the token type. Token type is of type fields 2, and it returns the balance. It returns the balance, right? Right, the balance. Also type fields. Yep. So we are simply just going to return the query of the account balance. So we're just going to query the account balance, supplying the address and the token type. And we're just simply going to return whatever we get from there. Next up, we're going to be creating our next view function, which is going to be the get pool token balance. So we're going to call this the get pool token balance. Now this one takes in just I think the token type. Takes in just the token type. Sorry, just complicated things. Right. Takes in just token type, which is of type fields. Yeah, and it returns the pool balance. Returns the pool balance, which is also of type failed. So we're just simply going to query the pool balance storage variable, right? Supplying the token type. And we're going to return whatever we get from that too. All right, so next up, we're going to move to our external functions. That's really real funny. So we're simply going to like call these externals, and we're going to start from the first external function, which is the set pool token balance. The set pool token balance. Oh my god. Set pool token balance. Yeah. So the set pool token balance, let's see what it takes in from here. It takes in the token type and the balance. A token type of type field and the balance, which of type field too. All right, so what we are going to do here is we're simply going to call the pool balance. So, okay, firstly, we want to check that our balance, right, does not, it also exceed the balance upper bound. So it takes in, let me confirm this, token type and balance, right? So we're simply going to through an error message. We want to throw an error message if it exceeds our balance. Let's just say AMM exceeds, let's see, exceeds maximum allowed tokens, right? And yeah, so what we want to check here is we want to assert that it is non-negative and it is less than or equal to the that's the balance is less than or equal to our balance upper bound -1. And we are simply going to just, once we are done, we are simply just going to call the pool balance, this storage variable. We're going to call the pool balance, and we're going to write to read the token type. The token type and the balance. So it takes in this key and we are storing this value in it. So I'm simply going to say token type and balance, and then we're going to return. All right. So having set our pool token balance, the next external function we're going to be implementing is the add demo token. So we are simply going to come down external. We're going to call this add demo token. The add demo token takes in let's see what it takes in from here. Takes in the token A amount. All right, takes in the token A amount. And then the token, which is of type failed, and then the token B amount, which is also of type failed. And we can, if we go back, we'll see that the first thing, it delegates logic to modify account balance function, right? It delegates the logic to modify account balance function. So to do that, basically, we're going to, first of all, let's check. All right, okay. This was not done in the initial implementation, but let's check that the where EMM. I want to check that this demo token we are adding does not exceed maximum allowed tokens to. So basically, we are adding these demo tokens to our wallet, right? Would there be any need to check for this? Okay, adding this to this goes into our wallet. Yeah, let's just check for it. Let's check that those exceed maximum allowed tokens. All right, and what do I do here? here. Okay. And inside here, we want to simply also assert that token E amount, token E amount does not exceed the balance upper bound -1. Let's check for this. We're also going to still check for, we're still also going to check for this too, for token B, but we're just simply going to copy this and the same thing. Yep. And once we do that, I mean, to be consistent, let me just remove that gap here for a second. Yeah. Then once we have done that, we are simply going to delegate our logic to the modifier account balance, the internal function modifier account balance. So you're going to simply say modifier account balance. And if we check what the modifier account balance takes, we'll see that right, this is it. It takes in the address, the token type, and the amount. So we are simply going to pass the address. The address, we haven't gotten that right. So that was, let's just use their local count to ensure that our address doesn't get removed, right? And you can see, let's call up. We go to the caller address. Caller address. All right. So having gotten the caller, once we're going to call the modifier account balance, passing in the caller, that's the address, the token type, and the amounts. So we're going to first of all be modifying the account balance for our first token, that's token E. So we're going to call passing the caller as the first thing. We're going to pass in token type E, which is a constant from earlier, a constant we specified earlier. And we are going to pass in the last thing we're going to pass in is the amount, right? The token E amount. Yep. So once we do that, I'm just going to copy this since it's the same thing basically for the second token. I'm just going to also modify account balance this time around for token type B and for token B amount. Yep. And having done that, we are just simply going to return. Yeah. Next, we are going to implement our next external function, which is the init pool. The init pool external function. So I want to name this to init pool. Now the init pool takes in the two tokens amount and tokens we're initializing. That's the amounts basically. Token E fields. Yep, token B fields. So these are amounts, okay, token E fields, then token B, yeah, fields. All right. Now these are also token, well, also like initializing pool basically means we initially deposited tokens, right? When we created tokens for our wallet, when we use this add demo token, we added some demo tokens to our wallet. So we want to initialize pool basically now by taking some of these demo tokens we added earlier to create, let's say, to create the first pool of tokens, right? So to initialize the pool, we want to first of all, we want to make sure that we want to put into checks. So I think we'll use the root attribute error message. And I'm going to throw an error message saying exceeds maximum allowed pool tokens. Let's call this pool tokens. Yep. And basically we want to check that, want to assert that is not negative. First, the second is less than, that is token E. Want to assert that token E, the amount of token E is less than our pool upper bound -1. We're just going to copy that since we're going to repeat that to our token B. So we're going to copy this and paste this here, and going to say want to assert same for token B, yeah, and having putting those checks, we are simply going to call what's the set pool balance function. So the set pool balance is an external function we already created earlier. So we are going to call the set pool token balance for both token types. Mostly we're going to do that for set pool token balance. The set pool token balance takes in token type and the balance. So we're going to say for the token type, we are passing in token type E. And for the balance, our balance token E. All right, then we are going to do same set pool token balance. This time around, we're passing in the token type B, and we are using the token B here. All right, once we do that, we're simply going to return. Yeah. So once we've done these boats, sorry, my phone is ringing. Let me just put it in do not disturb. Okay, yeah, sure. So let's continue. Then we are going to move to our next external function. I think is the last, that's the swap function. So we're going to see at external, right? We're trying to implement the swap function here. The swap function takes in a long list of arguments that the token from type field. It takes in the amount from, okay, takes in the amount from of type fields, and okay, sorry, the token from and the amount from, and then it returns the amount to the amount that the caller will be receiving after the swap operation is carried out as the amount to. And we're also going to be using the alloc lookout keyword to ensure we don't have revoked references. I'm simply just going to get, at this point, I'm going to get the caller. I'm going to let the guy be called the get caller address. Then if we check our swap function, right, we need to check that token is allowed in pool first. We check that the token is allowed in pool first. Then we go ahead to check the amount from doesn't exceed balance upper bound. All right. Then we check that user has enough funds. Then we call the do swap function. Okay. So let's start with the first check. That's that token is allowed in pool. All right. Now to check that the token is allowed in pool, right? We need to get the both tokens, and we would do that. We already have the token from here. Okay. We have the token from here. Oh, okay. All right. With attributes, the error message here. Okay. And for this error message, we want to show that okay, token is not allowed in pool. Token is not allowed in the pool. Yep. And now this is going to be tricky because we want to check now. An easier way to have done this maybe in some other programming languages is to check that the token from is equal to our constant token type A or is equal to our constant token type B, and if not, we'll probably return that it's not equal to them. I can try an error message. But now Cairo does not have like all like that or is equal to, yeah, the all conditional, right? It doesn't have it. So a way to do this, right, is using like simple mathematics. So we can do something like I want to assert that the token from, right, the token from minus, I'll explain this logic once I'm done. Token from minus token type E, right, times times token. This is a good way to do or in Cairo and in every other language that does not allow the or conditional. You can see token top from here. This is going to be token from minus token type B, token type B. All right. Then we expect that it is going to be equal to 0. Now, what we are doing here is that we are checking that token from minus token type A. What exactly this means is if token from is token type A, right? This minus this will give us 0. And we know that 0 times anything will give us 0. So it means that if either of this, if token from is either of any of these two tokens, right? It means it must be able to turn one of these brackets into 0. And if you multiply 0 by any other thing, you get 0. I don't know if you understand that. If you don't understand, you can ask a question. But the whole idea is, okay, if token from is token type A, right? Token type A minus token type A will give us 0. And 0 times whatever was here, if this give us 1 or whatever it is, will give us 0 too. But if token from was equal to token type B time minus token type B will give us 0. And 0 times whatever that was here will still give us 0. But in the case where probably token from was neither of this, and maybe it was token type C, right? Token type C minus token type A cannot give us 0. And token type C minus token type B cannot give us 0. So it belongs in the pool because it's neither of these tokens. I don't know if you understand that. Some persons are called. Right. Okay. Yeah, okay, sure. So let's just move on. Right, sorry about that. Okay, so once we check that, okay, what's the next thing we need to check for, right? Once we check the balance of our bounds, so we are simply going to see we use it with attributes, right? Let's see with attributes, error message, and we're going to call say EMM. We're going to say exceeds maximum allowed right. Okay, and inside here we simply want to check on us that no negatives are equal to that the amount from this guy here, the amount from is less than our balance upper bounds minus 1. Simple. So once we do that, we complete our second check. The next check we're going to check is we're going to check that the user has enough funds because the user cannot be trying to swap what he doesn't have yet. So to do that, we would need to first of all query for the user's account balance. We're simply going to say let's account balance as the user's account balance now. We want to say let it be equal to, we have the getter function for getting account balance. That's the get account token balance. And we're going to pass the address and token type. So we are simply going to call the get account token balance. And we're going to pass in the token type, right? What's the account and token type? The get account token, the accounts as the address here. Sorry, the address here, which is the caller in our case. Sorry, not address. The caller and the token type, which is token from. So we want to get the balance of the user's wallet. Now, once we get the balance of the user's wallet, so what we want to do is we want to throw an error with attributes, error message. I want to see EMM insufficient. Let's just say insufficient funds. All right. So what we're going to do is we're going to use, we're simply going to do the assert is like equal to and we're going to assert that the amount from, that's the amount user is trying to convert, is less than or equal to his account balance. Yep. So if it is not, we're going to throw that error. Now, once we've completed that check, right, the next thing we need to do, as for the swap, right, is we need to get the opposite token. We need to get the opposite token. Like I said, we're going to do that using an internal function we created earlier. So we're just simply going to select let opposite token, right? Let opposite token be equal to, yeah, we're going to make it equal to that internal function. Get opposite token. Get opposite, get opposite token. All right. Now the get opposite token, as you can see here, it accepts a token type argument. So we're going to, for our token type, we're going to pass in the token from. Okay. And once we get the opposite token, we want to call the do swap function, then return the amount to. So we're going to simply say let's amount to be equal to, I'm going to make a call to the internal function do swap. Do swap takes in the caller, takes in the caller, takes in the token from, then it takes in the token to. For us, our token to is our opposite token. So let's just change this instead, the token to let token to. All right, so we are going to say it takes in the token to, then it takes in last argument is the amount from, perfect. So once we have made a call to this, we are going to simply return the amount to, we're going to return the amount to, oh, yeah, we're going to return the amount to. Here's the question. Yes, opposites, get opposites. Yeah, thanks. That's wrong. Get opposites. Let's get opposites token. All right. So having done that, we're going to now move to implementing our internal function. So we're just going to call this internals. Yeah. And for the internal function, like I said, they do not have decorators, but I'm still going to use the external to just bring out the function signature. And that can be like a pain in the ass to write. So just going to use the external decorators to bring out this function signature. Now, the first external function I'm looking to implement, right, is the modify account balance. The modify account balance. And the modify account balance, it takes in the address. Let's call this the address instead. The address of type fields. We fix in the token from, which is also of type fields. We fix in the token to, which is also of type fields, and it takes in the amount from, which is also of type fields. Yep. So once we do that, next thing we need to do is I'm going to use the lookout keyword also to ensure that this our reference does not get removed. Now we're going to get full token balance for both tokens, and to do that, we're going to first of all get, let's say we're going to say EMM from balance, right? I'm going to say that should be equal to, let's call the get full token balance. So we are getting the full token balance for both token, and for that we're going to pass in the token from first. All right, then we're still going to do same this time around, EMM2 balance. The EMM2 balance. For this, we're also going to call the get full token balance, and we're going to pass in the token to. Yep, we're going to pass in the token to here. All right. Now, I haven't gotten the both right. The next thing we need to do is we would calculate the amount to. I'm going to calculate the amount to. I'm going to calculate the amount to. Now, to do this, we're going to import something. We're going to import something called the unsigned DREM. Now, as we might know, or as we may know in Cairo, right? The first data type has like an issue with divisions. So when we try dividing in Cairo, sometimes, especially when it runs into remainder, you might actually get some very strange figures as compared to what you were probably intending to get. We covered that in one of the first classes in our bootcamp, right? You could probably check it out on our YouTube channel. So basically, a safe way to carry out divisions in Cairo is by using the unsigned div-rem method, which is also available, I think, in the math library. So we're just going to use that. So basically, what the unsigned div-rem does is it carries out the division and returns both it's called the dividend, right? It returns it and the remainder. So let's say we're trying to divide 10 by 3, right? It's going to return the 3 and the 1 too. So we are going to be using that for divisions. Now, but firstly, we want to try to understand how, like, the AMM, how to calculate the amount to that's the amount of the return tokens that should be returned to the user. We're going to learn how to calculate that. For that, we're going to head over. We're just going to head over. I think there's this we head over to cairoland.org. Just going to check. I'm going to paste this in the group. All right, this Cairo implementation in the Cairo program. So I'm going to try to share this in the chat now. Okay. All right. I just shared the link to the chat, right? So let me find the particular logic, right, for the swapping. Yep, so this is the calculation, right? You can just read up on it later to understand basically how it works. But to get the amount to right, we are going to use the AMM2 balance. We're going to times it by the amount from and divide it by the AMM from balance plus the amount from. So we are simply going to do amount to now, like I said earlier, it returns the dividend and the remainder, right? But we don't need the remainder, so we're just going to use this dash to like explain to the compiler that we don't need that value. So we are going to say we're going to call the unsigned div-rem, and the first thing we're going to pass in is, I think, the amount to, right? Okay, the amount to, so let me see that again. The amount EMM2 balance times the amount from, all right, the EMM2 balance, that's this EMM2 balance, and we're going to times it by the amount from. What stuff is making? Right, sorry about that. So the EMM2 balance times the amount from okay. And the second, as this is the upper value, the numerator, then for the lower value, right, we have the EMM from balance plus the amount from. So we have the EMM from balance times, plus the amount from. Okay. Yeah, let me confirm that's correct. The EMM from balance plus the amount from. Yeah. And for that, and that's how we get like the amount to. Now, next thing we're going to do, right? That's okay. I think. All right. This is not the right place to do this, right? This is modify account balance. Oh, sorry about this. I'm just going to close this out from here. Sorry about that. For the modify account balance, this is what we are supposed to do, and I was implementing the logic for the do swap rather. So we're just going to remove all this. This is not correct. The first thing we need to do is we are supposed to calculate the new balance, right? But to calculate the new balance, we need to get the old balance. So we're just simply going to say let old balance be equal to the get account token balance. All right, so we're going to call the get account token balance as this, right? And we're going to supply the address and the token type, which is in this case is our no, this is wrong. So how do nobody correct me when I was doing this? I don't know where my mind went to. So for the modifier account balance, actually, we just need the address, the token type, and the amount. We just need the address, the token type, and the amount. So we don't need the token to here. So we're going to get our account token balance, right? That's for the token from, so we need the account ID. And for this, we have the token from. Now, once we get this, we're going to simply like calculate the new balance, right? Let's call this the new balance. And we are going to say the new balance, it doesn't return a true tuple. We can just do this instead. The new balance is equal to the old balance. Yep, plus the amount from. Yeah. So once we get that, we just next thing I think we need to check that it doesn't exceed our balance upper bound. Okay, for that, let's calculate. We need to calculate. Okay, we've calculated our new balance, right? The next thing we need to do is to check that it doesn't exceed our balance upper bound. So to do that, basically, we're just going to use the with attribute error message, and we have EMM. And we're going to say exceeds error, we're going to true, right? Exceeds maximum allowed tokens, right? Exceeds maximum allowed tokens. Yep. Now for this, we're just simply going to assert non-negative greater than equal to that our new balance here over here, our new balance does not exceed our balance upper bound, now -1, right? So once we do that, sorry. So once we do that, right, we can now update our storage. So we're just going to simply call the account balance. Yep, the account balance, and we're going to write to it our new balance. So for the account, to write the account balance, right? So we're going to call the write the address in the token with the token from, and the amount is the new balance. New balance. All right, so once we do that, we're just simply going to return. So this is the internal function that takes care of the modifying account balance. So you write a local key, locals, but you don't use the local keyword. Why is that? Well, that's because I think you don't, it depends on when I use the local keyword, it's necessarily when the compiler throws a reference error despite using the alloc locales keyword. Because most times when you use the alloc locales keyword, you tend to like instruct the compiler, okay, I don't want you to revoke my reference. But when you use the local keyword, you're basically instructing the compiler, okay, this particular variable, I want it to store it like I think in the FP pointer, right? You want it to be like a permanent, you do not want it to be a temporary variable, basically. So, but I'm not really interested in creating local variables, but I resort to doing that only when probably when even we are locals keyword, your compiler still tends to throw a revoked reference error. In that case, you probably have to need to create like you need to create a more permanent type of that's a local variable instead. I don't know if that answers your question, CC.
Hello, can you hear me?
Yeah, I can hear you. I can hear you.
Okay, does it mean we have to wait for for the program to fail before we use the
No,
local?
no, not necessarily, not necessarily. You can still come here and still see the locale. You can still come here and see. It doesn't change anything basically. Just
Okay.
I think in one of those previous class we explained right the difference between the FP and the AP. I think the AP registers, right? So you write this is a more permanent type of variable than the variables created with the let and the temp var keywords. So the variables created with the let and the temp var keywords are like the temporary variables and can be easily revoked. What I'm saying is the compiler has gotten so better that most times when you add the alloc locales keywords, it tends to like save you the stress of creating local variables. You get, but you can still do this, and this is even like maybe a better way of doing this probably, right? It makes sense to make it a local variable. I don't think that you get that.
Yes, yes, thank you.
Okay. Well, for now, let's just do this here. Just prepare writing stuff this way. Yeah, and yeah, so yeah, and that's sorts our modify account balance logic, right? So we're simply going to create our next internal function. I'm going to just remove this guy here. And so our next internal function we're going to implement is the get opposite token. So let's just call this the get opposite token. Now the get opposite token takes in I think just the token type. So we're going to say token type is spelled. Now this is going to do something very basic. We're just simply going to say if we're going to simply say if token type is probably equal to which is this single, so we use double equal to in Cairo. I actually forgot to answer that stuff. Oh yeah, it's actually double. That means I think there was a place I was supposed to use single, that I had to use double. Can't remember. That was where we had to calculate, okay, so single. Yeah, so this is actually supposed to be double, not single. Yeah, so if token type is equal to, let me check what token type is, right? And if it's equal, you just simply want to return, we simply want to return token type B. Yeah, want to return token type B. Yeah, else else we just want to return, we want to return token type B. Yeah. So I'm sorry guys, if I'm making a lot of errors. I'm just like super sleepy currently. Yeah. So well, we are definitely going to get this done. Yeah, get opposite token. Yeah, the last function is the do swap function. So I'm just going to move over this external function, remove this guy here, and I'm going to call this do swap function. Now, the swap function takes in the address, right? Yep, the address, the token from, yep, the token to, yep, um, the amount from, yeah, the amount from basically. So, we're still going to use the local cost keyword. So I don't really those annoying root references error. Now we're going to go back to, I think it says we need to get pull from balance, right? Yeah, we are going to get the pool token balance. And the pool token balance. Yeah. The pool token balance just takes in token type. And want to get 42 EMM2 balance. All right, the get pool, not that, sorry. Get full token balance, and this time around we want to get for the token 2. Okay, that's wrong. Not EMM. Yep. Then the next thing we were supposed to do was to calculate the amount. So I think we did that thing there, like, yeah, still have that. So basically, I explained we used the unsigned derivatives method we imported to like help calculate like do divisions in such a way, in a secure way, right? To do the divisions in a secure way. So once we've calculated the amount, I want to modify the from balances. To modify the from balances, first of all, I want to modify the from account balance. Now, to do that, basically, now we know that if the user wants to swap from the token from, right, it's token type A, right, it means that the user is going to lose the amount of token type A he wants to swap from. So we are simply going to call I think for that we're going to call the modify account balance. That's this internal function from earlier. All right. And the modify account balance, we are going to pass in our address. I don't think we have that. Okay, we do have that. That's supplied as an argument. The address, okay. And the next thing we need to pass into modify account balance is the token type on swap from. So that's a token from is swapping from. All right, then the amount here is okay, we want to modify the account balance after taking out the swap. So the amount is going to be in minus of amount from. Okay. Does anybody understand why we had to use a minus sign instead? Can anybody probably explain that? Or should I just always a better question, is anyone confused as regards to that? Not really. Okay. The reason why I had to use a minus sign is if you go to our modify account balance, right, you notice that it takes in the amount from, and what it does is it does new balance is equal to old balance plus amount from. Now, like I explained earlier, the token from will be subtracted from the user's account. So let's say Victor wants to swap with our EMM, right? And Victor is putting in token type A to get token type B. It means he will use token type A to gain token type B. Is that not true? So it means that if we are going to use this internal function modify account balance, we must have to supply the minus sign. So what exactly this minus sign does is in primary school maths, right? Yes, that's right. Here we do old balance plus amount from. So basically what is happening here now is we are doing old balance. This, I think, basic maths, right? Old balance. I mean old balance plus minus amount from. And we are taught that when plus or minus collide together, right? Minus overrides plus. So basically, automatically, we are having old balance minus amount from instead of old balance plus amount from. I don't know if that is clear. Is that clear? Or is there any questions as regards to that? All right, sure. Then the next thing we're going to modify, right, is okay. The next thing now is we want to modify. Okay, let's just before we go over to modifying the pool balances, right? Let's also modify users account balance also for the two tokens. So we're going to say address. This time around is token two, and the amount is going to be amount to. Sorry about that. The amount to. So this is going to just be the amount to. It's not going to be amount minus amount to because The amount basically is coming into the user's wallet. So we need to add it. We don't need to subtract it. So we're just going to use the amount instead. Then we are going to do for the pools, right? So we're going to do for the pools. Now for the pool, the front pool, right? So we're going to use the set pool token balance for that. We're going to call the set pool token balance. Now that takes in the token type. We're going to do from first. And for the pool, it's exactly the opposite of the account, because while the account is losing, let's say token from was token A and token 2 is token B, right? While the user is losing token A will be added to like the pool. So we are going to be having token inside here. This is going to be a positive, this is going to be amount row. It's going to be positive, right? It's going to be positive. And the pool is going to be using some amount of token too, since it will be going into the user's wallet. So we are simply going to run the set pool token balance again. But this time around for token 2, and for token 2, we are going to be doing minus amount to, yeah. And having done that, I think we can now return. And returning, all right, returning basically, we are supposed to return amount, okay? So return, we are supposed to return amount to, so I'm just going to come here and I'm going to do this amount to health. And I'm just going to come and see amount to, shall we go to amount to, yeah. All right, so let's go back to our swap function, amount to return amount to, okay. Sorry, is there no way to avoid the negative argument? Well, to avoid the negative arguments will mean complicating your code further, because to do that, you probably have to like implement a different internal, let's say a different internal function for positive, for adding, as in for addition operations, and a separate internal function for subtraction operations. So you're going to say that if we are trying to modify account balance and it's an addition operation, we are probably going to call a separate internal function. And if we want to modify account balance for, let's say, subtraction operation, we are going to call a different internal function, which also is plausible. Basically, your compiler understands it, but then codes go beyond just your compiler understanding it, right? Your code base might probably be managed by another person in the future. So it's always better to keep it as clean and as simple as possible. I don't know if you understand that, Sissy. Yeah, you're welcome. So let's just head over to compiling this and let's see if we did a great work. Because if we did not, Photoshop is going to shout at us. So let's just go over here and uncomment EMM. So where's EMM here? I'm going to uncomment this guy. And we're going to head over to our terminal. Yep. And run road to start build. I'm going to clear this. This was from the last class and it's a pink clunky. So let's run to start build. Road to start build. All right. Okay, we have an error. Basically, why are you seeing that comment? So you're not supposed to see that. Oh, because those joints. Preston, sorry about that. Okay, yeah, and because we're supposed to have this instead. Yeah. Okay. All right, so expected zero unpacking identifier found one. expected zero, unpacking identifier found once. Let's go back to the get. Not same words number. 110, 10. Okay, 110. Let's go there. Number 110. So left token to be equal to get opposing token from. Okay, I think my get opposing token. Oh, okay, this is supposed to return something. Supposed to return let's just see, it's supposed to return type of token, right? Okay. Sorry about that. Please give me a minute. Let me sort out something. Okay, yeah. Sorry for that. Yeah, I'm here. I'm here. Sorry for that brief interruption. Let's move over to sorting out all these errors. So, number one, so expected expression of type amount to failed, good failed. Okay. 112, 112 was wrong at 112. Return amount to, okay, return amount to. All right, so let's come back to this. All right, so let's run this again. All right, we have an error, another error. So we good expression. Let's 13717. Okay, 13717. All right,
Yeah, I think it's from. I can't hear him too. I don't know. Darlington,
Yeah,
are you still there?
I'm back. My network cut me off initially.
Okay.
Right, I'll just share my screen and okay. Yeah, so I was actually trying to declare my contract. I was trying to declare my contract while when I left. So I'm just going to run this command. And I think I've got my private key set from the last class. Yeah, so we have everything. So this was successfully declared, right? So I'm just going to check this out on StackScan. We were successful with our declaration. Yeah. Okay, sorry about the slow internet connection. Okay, class does not exist. It means it wasn't successfully declared. So while we wait, I'll just go check out the transaction to be sure that it didn't get rejected, probably due to fee errors. I'm just going to go here and check out the transaction. Okay, yeah, it was actually declared successfully. So let's go check the class hash again. Over here, I still can't find my class hash, but it says it was declared successfully. So what exactly might be wrong? Coming. Okay, F22. My network is testnet, right? Yeah. My class hash ends with F22, which is same as this guy here. Let's check. Oh, right, he exists. Okay, so this is the ABI of our contract. You can see the get account token balance and some other functions contained in our contract. So we're just going to try deploying that. We're going to run the deploy command, protestar, out of time, protestar deploy, and we're just going to paste our class hash, which is this guy here. Yep, this guy. We're going to paste the class hash. And it doesn't have a constructor, so there are no inputs basically. So I'm just going to specify the network. Network. Let me specify my account address, right? Account address. Okay, which is here. The network, which is on testnet, and the max fee, which is auto. So with that, let's try deploying. All right, so we have our contract address deployed. So I'm just going to monitor the transaction to see when it gets accepted on L2 or whether I go rejected. I'm just going to monitor this guy. Okay, it got received, so it should, okay. Going to dependent state soonest. Yeah, so while we wait for that, once that is deployed, we'll try interacting and playing around with that contract. So but while we wait for that, right, so we're going to go back into our repo, head back to the README. README is more like a documentation. So we're just going to head back to it, and now we're going to check out the messaging bridge. The messaging bridge exercise next, right? So if it's your first time hearing about messaging bridges, I'm going to try to break this down to as simple as I can, but I think we have a very in-depth messaging bridge course which was handled by a developer advocate or at Stackware. At our last StarkNet Bootcamp. So you could just head over to our YouTube channel. Paul probably could help me post the link to like YouTube channel. So probably could people who are not around during the bootcamp could probably check out some of all these stuff in YouTube channel. Yeah, Paul, can you hear me? Right, guys, can you hear me, or am I speaking to myself?
Yes, I can hear you from this end.
Right, I probably Paul is currently not available. Okay, let's just move forward. I'll probably paste that towards the end of the call. So let's just check out our contract. I think is deployed. And I'm going to go into the right contract. The right contract is account token balance and get pools token balance. So let's start with the right contract. So we're going to connect our wallet and demo tokens to our account. So for token A amount, we're going to put in 1,000, and then we are going to write. We're going to start from there. The demo tokens, and my network is a bit too slow. All right, so we're going to approve this transaction. Now, once the transaction is done, we are going to go ahead to initialize a pool of tokens. Probably we're going to just do 100. And once we initialize pool, we are then going to also go ahead to carry out a swap and see what the swap function looks like. All right, this is still loading up, so yep. All right, well, wait for that. Let's just go back to the repo. That should be done in a matter of minutes. All right, so like I said earlier, we're going to be okay. That's loading up. Let's just move over to that. So having initialized, someone has a question. All right, thanks a lot. Thanks a lot, CC. Yeah, so now if you go back to our lead contract, right, I'll try to get account token balance for my address. For this address, right, so you paste this in, and the token type is, well, one. I'm trying to query, right? Yeah, you get back 1,000. So we're just going to go back to write contracts, connect our wallets, and then we're going to try initializing a pool. I'm going to do 100, and I'm going to do 100, and I'm going to write. I'm going to initialize a pool using 100 tokens, right? And I'm going to approve this. All right, so once that is approved, next thing we're going to do is we're going to try swapping our tokens. We're going to try swapping our tokens. All right. Okay, yeah, that has gone. So next thing we're going to head over to swap. Now our token from, we're going to use 1. Now, okay, this is now a bit of an issue because, okay, yeah, token type is 1, token type is 2. Okay. Yeah, okay. Token from, let's just use 1, that's token type A. Amount from, I'm just going to say, let's swap 30, and we're going to write transaction failure is predicted. Why? The assertion error, this is out of range. Interesting. Token from 1, amount from 30. Why is that out of range? And this has 100 and 100, right? We've added demo to initialize our pool. And now we are trying to swap. Okay. Let me confirm something. All right, the chat. How come we are not converting the integers to fields before usage? Well, basically, in the defaults, the defaulting accepted by StarkScan itself is in field. So But close this now and you remove this, right? You can see integer or hex example 1 or 0x1, but then it is converted to fields behind the scene. Basically, it is converted to fields behind the scene. I don't know if you get that because our data type already was specified as fields. All right, so I'm trying to understand why I'm running into errors here. Is out of range, okay. Okay. Let me confirm something. If you go over here and you try to get pool token balance, all right, and I read for 1, I should get 100, right? If I read for 2, I should also get 100. If I come here to the account token balance for this account address, yep, and I read for 1, I should get like 900 or I still have 1,000. Interesting. Okay, so I go back here and I connect to my wallet. I've added demo tokens, right? I've initialized pool, and now I want to swap. So the token from basically, I want it to be 1, and the amount from the pool has 100 tokens, 100. So let's try swapping 10. I still run into this error. Oh, right. Sorry about. Okay. Nope. No, that's not it because let me go back to my codes. Let me see what the swap function does again. So it doesn't throw either of these errors. I'm sure of it because if it does, it should throw the custom error we had created in here. So it's neither of those errors. Exceeds maximum allowed tokens, EMM insufficient balance. And it's neither these two. Okay, guys, just to confirm that it's not an issue with our own codes, I'm just going to run, I'm going to try testing the last contract we wrote. I'm going to try testing the EMM contract, which, okay, that's just the one I wrote earlier. And I'm going to do this one. This one was done on testnet 2, right? So I'm just going to tell you about testnet 2. I'm trying to play around with that. I'm going to switch over to testnet 2 on over here. I'm going to come here, testnet 2. Yeah, testnet 2. All right, I'm going to look for that address. Yeah, it's an AMM address, AMM contract. I'm going to connect my wallet, Agent X, and I'm going to add demo tokens firstly. I'm going to say 100. Okay, let's just say 1,000, 1,000. Okay, and I'm going to write, I'm going to approve this, wait for a while. Once that's completed, we're going to initialize the pool, and then we're going to try swapping. So come on. Okay. Seems like testnet 2 is even taking more time than testnet 1, which is a problem. We don't have so much time to waste. I'm going to still test that because I want to be sure as to why that is misbehaving. I think I wrote test for this earlier, and I think the test passed. Go back to the tests, right, and test the EMM. So basically, for the swap, start rank this, right? We initialize pool, then we add demo tokens. All right. Does that mean I've been? Oh, interesting. I think I got the whole process wrong. So we are supposed to initialize a pool for both tokens before like adding demo tokens and then trying to swap. Should that be the reason why we run into those errors? Hey guys, let me try something else. So if I go back here to read the contract, I think the account balance is 1,000, but if I read for the pool balance, I get 100. Oh, okay. Option. Testnet, connect. This on testnet, so testnet. Let's connect wallet. Agents. Oh, we have testnet one now. Yeah. So we're going to try this time around. I'm going to initialize pool. We're just going to set pool token balance instead. I'm going to set for token one, right? I'm going to set 10,000. Let me confirm something. When the transaction is going to, I'm going to also set for the second pool, that's the second token pool, the same 10,000. So let me confirm if that's where the error is coming from. So we did same here, 1,000, 15. All right, oh, what's that? Let's complete this guy here. Let's spin around this guy. So once we are done setting the pool token balance, we are just going to go ahead to call swap and see if that works. Yeah, let's go ahead to call the swap. Token one, I want swap 100. Let's see if that works. It still shows error, and that's not the issue. Well, guys, we run out of time. I'll try to like debug that and probably let us know why I am having issues with that. It's been a while since I wrote that, and I think there was a test for it, right? And this test passed, so this must have either been an issue with our logic or something. I'm just going to check that later, but for now, let's go into the main order of the day, right? And that's the messaging bridge and the upgradability. So, okay. So before we proceed, basically, I just want to know, does anybody have any questions probably that we might need to attend to before we move forward? We've just got, I think, an hour, 9 minutes to run through the messaging bridge and upgradability contract. So does anyone have any questions as regards to the AMM or something we need to check out before we move on? All right, if not, then let's just proceed. Let's run. Okay, so basically the a feature that actually makes StarkNet stands out a lot, right, is the ability to like interact with the underlying layer one. So when we talk about messaging bridges, in fact, when we talk about bridges generally, or in blockchains, right, in the ecosystem, the first thing that goes to our mind is bridges used for asset transfers. So basically think about thematic bridge, the wormhole, and the rest of all the popular bridges, Harmony and the rest that people use for transferring assets from one chain to another. But the StarkNet messaging bridge is a little bit different from those because it goes beyond data transfer. Sorry, it goes beyond asset transfer into what we call data transfer. So on StarkNet, basically, you can easily create messaging bridges for like data and asset transfers between StarkNet, your application on StarkNet, and probably another smart contract existing on Ethereum. That's the underlying layer one. So in this project, basically, we are going to be creating an example of a messaging bridge. This time around, I'm going to be working on an ERC20 messaging bridge, basically, that can help a user transfer an ERC20 token between StarkNet and Ethereum. So basically, the thought process for this application is think about, let's say we have an ERC20 token already deployed on StarkNet, right? And we intend bridging this token now that's been deployed on StarkNet to Ethereum to enable users send their tokens between layers. So let's say we created the StarkNet African token on StarkNet, and we are intending users to be able to bridge StarkNet Africa tokens to Ethereum, like send their tokens between StarkNet and Ethereum, right? What we're going to do here is we're going to, first of all, we're going to deploy a clone of our ERC20 token on Ethereum, something very similar on Ethereum, but this time around is going to have zero initial supply. So we want to do this to ensure that we have total supply. The total supply across like the different layers remains constant. So when you sum it up, it remains constant, right? So when we do this, right, we are then going to deploy our token bridge on both layers, setting the ERC20 token we want to particularly bridge. So each time a bridge happens from L2 to L1, what happens is that the bridge tokens are locked in the L2 bridge contract. So think about the way this works, right? We have a bridge contract on L1. We have a bridge contract on L2. So L2 in this case is StarkNet, L1 is Ethereum. So we'll probably just use StarkNet and Ethereum instead of L1 and L2. That can be confusing. So let's say each time we want to bridge, right, from StarkNet to Ethereum, we're going to lock a certain amount, that amount of tokens we want to bridge to Ethereum on our bridge on StarkNet, and then on the layer 1 that's on Ethereum for the user. So, but each time the user wants to go back from layer 1 to layer 2, right, what's going to happen is we're going to burn that particular amount of tokens on the layer 1, right? And then we are going to transfer that same amount of tokens from the bridges assets, that's the tokens that the bridges have in its accounts, right? We're going to transfer that particular amount from the L2 bridge, that's the StarkNet bridge, to the user on L2, that's the user on StarkNet. So doing this will help like keep our total supply constant. So that's just basically the logic behind this. So we are going to be building this. We're going to be building this. And if you head into the source folder, right, and you head into the main messaging bridge, you're going to see the layer 2 contract, which is what we are going to be focusing on. So first of all, we have an ERC20 contract, which we are not going to be building in this class, since we already looked at ERC20 contracts in our first class. So secondly, we have a token bridge here, token bridge of Cairo. This is the contracts we are actually going to be working on and trying to understand. And then if we go over to the solidity part of things, sorry, the Ethereum part of things, right? The layer one contract is written with solidity and hard hat. So if you head over to the contract folder, you head into the contract folder, you can see we have the token. So the token, it contains there are 20 contracts we are going to be deploying on StarkNet, on Ethereum, sorry. This is the ERC20 contracts we are going to deploy on Ethereum. So it simply imports from OpenZeppelin and then creates an ERC20 token out of it. And we use the modifier to ensure that when we use the only owner modifier, right, we want to ensure that the message of sender is equal to the bridge contract, right? So simply put, we're going to, when we are deploying this ERC20 contracts, we're going to set our L1 bridge contracts. And then we're going to we have the function, the mint function and the bond function, which can only be called by the bridge contract. No other person can call like these functions. So once, okay, having done that, we then have the StarkNet core.sol. So this is an interface for the core contract on Ethereum. That's StarkNet's core contract on Ethereum. So we all know that rollups exist as smart contracts on Ethereum. StarkNet is no different. So this is the interface for StarkNet's core contract on Ethereum. This it's like the interface for the parts that has to do with like messaging bridges, that's accepting messages, consuming messages, and canceling messages, and so on. So we are going to be importing and using this interface, right? Then lastly, the last contract we have here is our token bridge.soul. So I'm going to explain this contract for us. This is Solidity contract. I'm going to explain this, but since Solidity is not like the main goal of these tutorials, right? We are not going to be writing this ourselves. We're just going to be focusing, we're mostly going to be focusing on the L2 side of things. So how exactly can we code up a messaging bridge, like an ERC20 bridge for assets transfers, or for an ERC20 token transfer, right? So we're just going to, if you head into your if you head into, okay, if you head into the Min messaging, let me just close this and close all this for now. Yep. If you head into the messaging bridge, right, the messaging bridge folder, head into L1, you could see everything is there. Everything is there, but if you head into L2, you would see that we just have the interface and the token. The token is here. We learned to create an ERC20 token in the first class we had, so we're not going to be going over this again to save time. We are going to be looking at creating this token bridge, right? This is what we're going to be working on. And as always, we're just going to, first we're going to be trying to like, okay. I'm just first of all going to try to like understand the logic, what exactly does the logic do. So I'm just going to minimize this. Yep. So basically the first thing we had to do was imported the ERC20 interface, since we're going to be using that in this contract, in this bridge contract. We imported that from the Min messaging bridge L2 token, right? Min messaging bridge L2 token ERC20. So imported from that namespace from there. So we are going to be creating storage variables, right? So let's call this our storage variables. All right, so the first storage variable we're going to be creating is the token L2 address. So basically, this particular storage variable stores the address of the ERC20 token on like the layer 2, right? Then we have the bridge L1 address, the bridge L1 address. So the bridge L1 address stores the address of the bridge on the layer 1. And we have the admin address. So the admin address basically stores the address of the bridge admin, the address of the bridge admin. Then we have a constructor. So we have a constructor which takes in, the constructor takes in the L2 address and an admin address. It takes in an L2 address and an admin address, and basically initializes this as in the both variables, right? So once we initialize this on deployment, then we have external. So in this one, we don't have getter functions in this particular bridge contract. So next steps are the external functions, right? The externals. All right. So the external function basically, the first external function we have is the set bridge L1 address. Okay, the set bridge. Why do I make a mistake? The set bridge L1 address. So this particular one takes in just an L1 address. You can see that in the interface. Takes in the address, and basically, first of all, the function can only be set by the bridge admin. So we're going to check we are going to check that caller is admin, right? And we are simply going to set the bridge L1 address. Yeah. So once the next external function we have here is the withdraw to L1. The withdraw to L1. So the withdraw to L1 is basically responsible for the withdrawal logic, right? The logic that communicates, that sends message to the layer one, right? So this takes in it takes in the amount and the address, right? So what exactly are we supposed to do, right? So the first thing we need to do is we want to lock the token in bridge contracts, right? I want to lock the token in bridge contracts. Now we're going to be a transfer from here, and as we all know, if we're going to do a transfer from, it means we're going to need to approve the contract to transfer funds from our wallet before using as in withdrawing to a loan, right? So we're going to lock the token in the bridge contracts. Then we are going to construct our payload. Next thing we're going to do is we're going to construct our payload. We're going to construct our payload. Then finally, we are going to send message to L1. We're going to call the send message to L1, which is a method would import from the system call libraries, as you can see here. As you can see here, it's a method we can import from starknet.common.messages. We can import the same message to L1. And to that, we are going to pass the L1 bridge address we are sending, the amount of the messages, like the call data length and the message payload. That's the message payload length and the message payload, right? So for the message payload, as you can see here, the message payload, we are sending an L1 address. We are sending the amount.low and the amount.high. So we are basically breaking, since our amount in this case, since we're dealing with an ERS-20 standard is a unit 256, we are going to be breaking that into amount low and amount high, and on Solidity, we are going to try to compile it. So I would explain that when we get to Solidity contracts. But just know that we are going to be breaking the message payload into the amount low and the amount high. And then we're going to call the send message to L1. So once we do that, next thing we're going to do, the next function we're going to create. Okay, let's actually get that function. I just put it down. The next function we're going to create, right, is a deposit to L2. The deposit to L2. Well, the deposit to L2 basically, I think, do I have, okay, the interface is not here, which is an issue. So I'm just going to create the interface. Deposit to L2, basically, it takes in the from address, the user address. I'm going to explain what exactly this does. The user address, the amount low, and the amount high. Now, when we go back to our Solidity contract, you'll notice that when we call the function basically that sends the message to L2, right? You notice this from address argument is not included as an argument, right? Because this is automatically supplied by the StarkNet core contract. You're going to properly understand that when we go into the Solidity contracts. But after we're going to, for this takes in this, right? And we're going to, what exactly does it do? So we would want to check that the L1 address is correct. We want to check L1 address is correct. And to do that, we're going to the L1 address is this from address is coming from. So we want to check that L1 address is correct. All right. Then if L1 address is correct, right, we simply want to like transfer the amount from like the bridges account, right? We want to transfer the amount on the bridge to like the user address specified. So we're going to transfer to the user address the amount to the user address. All right, the amount to user address. Yeah. So the last function we have here is a getter function. So the getter function, let's call this getter. A getter function basically is a very simple function. It's a very simple function called my balance. And basically what it does is, I think it just takes in an address. Sorry, this is supposed to be a comment. It just takes in an address and returns the balance of the address, the balance of the address. So basically, I think this is all we need. So we're just going to, as always, expand, then try writing out our own logic. So I'm going to call this token bridge dot Cairo. All right. So we're going to start as always with declaring our language directory presenting Min-StarkNet. Then from starkware.cairo common dot Cairo built-ins. All right, we want to import the hash built-in. Okay. Then also from starkware dot Cairo, okay. Yeah, dot Cairo dot common dot doing 256. From here, I want to import the 256 row. So we're going to be using that. Then from starkware dot starknet dot common messages. I think we want to import the send message to L1. Then from starkware.starknet.common.syscalls, we want to import the get call address. Okay, the get call address. All right. So having done that, the next thing we need to do, I'm just going to open this guy, split to the right. And the next thing we're going to do is create our storage variables, right? So the first storage variable we have here is the token L2 address. Let's move on a faster lane now because we have less time. Okay, token L2 address, and basically just stores the address of the RS20 token on StarkNet. Then we now have the next storage variable basically, which is the bridge L1 address. The bridge L1 address stores the address of the bridge on StarkNet, sorry, on Ethereum. Then we have the last one, that's the admin, which stores the address of the bridge admin. Okay. Then we have our constructor. So I'm just going to use external and to bring out the signature and then constructor. Right. Yep. Right. So I'm just going to call this constructor. Now, what does constructor accept? They accept arguments L2 address. Right. I'm going to be moving a little more faster. If you have questions, I'll drop it in the chat. L2 address and the admin address, which is auto type fields. All right. Then the auto address and the admin address. So we're simply going to store set those variables. So for the auto address, we're going to call it token L2 address. We're going to write to that guy, and what we write into him is the L2 address. Yeah. And then to the admin variable we want to write the admin address, the admin address. Okay, token auto address, right? Yeah, admin address. Yeah. And we're just simply going to return. And always return. Right in Cairo. Then I'm going to tell you what to. Let's just implement our getter first. I always prefer implementing that first. I don't know how I missed that. Okay, it's external. I'm going to just change this to a view. All right, this is going to be my balance. And to use that, I want to import something. I'm going to need to import from from source dot mean messaging bridge right bridge from source, then going to mean messaging bridge. Then you need to go into L2 dot token. And inside there, we're going to find the IS20 file. And from there, we're just going to import our interface. Yeah. All right. Okay. Yep, this is going to take an address. This is going to take an address of that fields. Yeah, that fields. And want to go for the balance, right? Yeah. So I'm going to let's just simply say, okay, let's just say let's balance. Mostly we're going to add this because once we've done it right, I'm going to say balance fields. Nope, balance you into 56. So we're going to say, yeah, we put it that let balance be equal to IS20 dot balance of, let's call the balance of function or method IS20 dot balance of the address, that address. Okay, we're going to supply the we need to supply the token L2 address first. So to do that, we're simply going to get that first. So we're going to see L2 address, L2 address will equal to token L2 address dot read. We're going to read from that. And yeah, if we read from that, we get the address, and that address we're going to supply it as a first argument. Then the second argument basically is going to be the address we want to read. All right. Yeah, then we're simply going to just return that balance. All right. Yeah. Having done that, I'm just simply going to go into our externals. Let's just type it right there. Yeah, it's externals. We're going to call the first external is to set the bridge L1 address. Set bridge L1 address, and yeah. The set bridge L1 address takes in the address parameter, field, and we want to check that. We check that caller is admin, right? So we're just simply going to say let's caller be equal to get by got that guy. Yeah, the get caller address. So I'm just going to call the get caller address. Yep. And I'm going to throw an error. All right. Error. Okay. Before then, I want to get the admin too. I want to let admin be equal to admin dot read. Yeah, admin dot read, right? Once gets read admin, and want to throw an error message that says bridge. Okay, in bridge, caller is not admin. caller is not admin. Yep. And yeah, basically want to assert that caller is equal to admin. And if that's not true, just throw an error, as what we just said here. Then if that is true, we want to set the bridge L1 address. So that's bridge L1 address. So we need to say bridge L1 address dot write and writing the address here. And we're simply going to return. All right, so having done that, the next function we need to implement is the withdraw to L1. Okay, that's going to be an external function, withdraw to L1. Okay, so before that we're going to takes in takes in an argument as the amount, which is in unit 6, and the L1 address, which is a felt value. And once we draw to L1, so firstly, okay. All right, so we are supposed to log the token in bridge contracts, construct our payload, and send message to L1. Okay, so let's start with getting our caller. So not sure, but let me just use a local count. So I don't run into any. Yeah, and I'm going to see let's caller be equal to get caller address. Yeah, and okay, let's caller be equal to get caller address. Yeah. Okay, next thing we might probably need is we're going to log token in bridge contract. We already have the amount of tokens we want to log. We would need to get the L2 token, token L2 address. So I'm going to see let's L2 address equal to L2 token L2 address, token L2 address, dot read to get that. Then to log, I'm simply going to see IRS frequency the transfer from. That's simply going to transfer from the token we are calling is the L2 address. So the first argument, then the caller. Okay, we need a third argument. We need a third, now this contract. And to get that, we probably have to come here and get the contract address too. So the get contract method. Get contract address, right? Yeah. And we're going to come here. Okay, this contract to equal to get contract address. Yeah. Then we're simply going to transfer from caller to this contract. Yeah. And also address caller this contract. All right, any other thing missing? The amount. This is the amount, right? Okay, so having done that, next thing we need to do is we need to construct our payload. All right, so to construct our payload, we're going to say let message payload, right? Message payload, which is message payload is type field for is going to allocate space in memory to it. Then I'm going to then begin to construct them. So message payload 0. All right, want to see message payload 0 is equal to so the message payload 0 is going to be equal to the caller. Yeah, caller That's correct, right? Then we're going to message period 1, which is going to be equal to amount, the amount, okay, yeah, the amount of load, okay. Then message period 2, our second message period, is going to be equal to the amount dot high. All right. So having constructed our message period, next thing we need to do, we call the send message to L1 method. And that accepts the L1 address he wants to send to. He accepts the number of payload 3. Lastly, accepts the message payload itself, the length of the message payload itself, right? And it all goes well, just return. Yep. I think we just completed that. Get this. Okay. Yeah. So the next function we need to implement, right, is an L1 handler. But I'm going to explain how to bring this to so I'm going to call this the L1 handler. Now, this L1 handler is a decorator. We talked about decorator in our first class, right? So this L1 handler is a decorator that specifies to our contract that this particular function accepts inputs from layer 1s. So when a message is sent from L2 to L1, 2 things happen. Okay, I think it's better while we explain. Okay, I'll explain this better when we head over to like the Solidity contract, because but what you should know at this point now is that this L1 handler accepts it's only functions that has this L1 handler decorator that can accept payloads from layer 1, like accept messages coming in from layer 1, message payloads coming in from layer 1s. So that's the purpose of the L1 handler decorator. So this L1 handler, this function is supposed to be what? It's supposed to be deposit to L2. So I'm going to call this deposit to L2, and deposit to L2 takes in a from address, which is of type felt, a user address, which is of type felt, an amount low, which is of type felt, and an amount high, which is of type felt. Yep. So having gotten all those, we want to do something. We're going to get, all right, we're going to get our initial bridge L1 address set. I want to say let's bridge address be equal to bridge L1 address, dot read. We're going to get the bridge address. Having gotten the bridge address, we want to check. I'm going to check that the L1 address is correct. So we're going to see address error message, and we're going to say bridge. So we're going to say bridge. All right, so we're going to say bridge. L1 address is incorrect. It's incorrect. All right. So once we do that, incorrect. Okay. Now once we do that, we're just going to go in and we're going to see we want to check that the from address is equal to the bridge address. If all things goes well, we'll probably have to continue. And next thing we need to do is transfer the amount to the user. So that's simple. We're just going to use the interface once again, call the transfer method. All right, and we're going to pass in that. We probably have to get we need to select let's open address. All right, let me see. Oh, let me see. Token address instead. Let me see token address. We go to token L2 address the reach. So we want to pass that in here. Okay. Yep. Let's pass that in here. Other arguments are going to be the person who we are depositing to. That's the user address. Now we need to pass in the amount as a unit 256, which we can get from combining the low and the high in the unit 256 struct. So we're going to say let amount in unit 256, all right, be equal to unit 256, unit 256 of the amount low and the amount high. Perfect. So we're going to come here and we're going to see the amount in 256 as we're going to be transferring, right? All right. So having done that, okay, having transferred, what else are we going to do? I don't think after transferring, I think that's where our stuff ends, right? Yeah. So having done all these, we've successfully completed our contract. So before I head over to like the Solidity contract to like carefully explain that, I want to first confirm that this compiles. Let L1 equals get L1 is same as let L1 equal to get L1 is same as nope. Nope. When you do you use this first one when you are actually the first assumption you give this, I don't know if you can see me highlighting your chart, right? Use this first one when you are trying to like read from, mostly when you're trying to read from storage variables or function, because in Cairo functions and storage variables most times return what we call a tuple. So you're going to have to use this unless it's going to throw you an error such as expected type of failed this but got failed. But you are going to use this. This, in fact, you can only use this without the brackets, only when you are carrying out, let's say, an arithmetic operation that doesn't read from a function or storage variable. I don't know if you get that. But you can't, when you are using get L1 with these two brackets, I'm assuming you're trying to read from, a function. So you will probably have to use the brackets around it. Yeah. So let's compile this basically and see if it works. So I'm just going to go into my prototype file. If you have questions, please ask in the chat. I know I was a little bit faster for this particular contract. So if you have any questions, please ask. All right. I'm going to uncomment this and I'm going to uncomment this. We didn't do the ERS-20 token though, but I want to assume we all know how to build ERS-20 tokens. So I'm just going to run the protostar build command, protostar testing build command, and is our contract trying to compile without an error? Yep, that would have been weird. All right, so unknown identity. Yeah, that's true. You're supposed to import a lock, but I don't know where that is from. Let me go check my messaging grid. Cairo Lang library should be this, okay? Let me just expand this guy. Right, so where does alloc hide? Okay, alloc should be in here. Yep. So we're going to go back up into our token page. And somewhere here we're going to just see from starkware.cairo.common.alloc. And I'm going to import, alloc. All right, so let's try that again. All right, now we have another error, unexpected after main said, which is future. Quite understood for 619 seems like I hit some silly error. For 619, so let's add main. Oh yeah, yes, we're going to make this. Let's admin address equal to admin.read. We're just simply going to make this admin address instead. Yep. Let's try once again. Okay. Let's hope it compiles. Oh well, another error. So in 26 registrants, unexpected this, expected that, a lot of expectations. Unexpected this after this, which is true. That's 85. It's 5, it's 5, it's 5, it's 5. Net amount in unit 26 equals to this. Okay. Transfer equal to this. So I'm just going to remove this here. Okay. I'm going to remove this here. And I'm going to come here and I'm going to say unit 26. And I'm going to say, let's create two brackets. And I'm going to call this amount low and amount high. Right, let me so that's so finally, so we have our contracts build up, so everything works now. That's 636. Well, what do you guys say? Should we deploy and test, or should we move? Okay, we have to explain. Let's explain solidity contracts first. But I just want to know you guys' thoughts. Should we try deploying the contract and playing around with it? Because messaging bridges take a very long while to like test and to play around with, because sending a message from L1 to L2 is super fast, it's very fast, but sending from L2 to L1 can take anywhere from 8 to 10 minutes and it can be very slow and annoying. So I don't know what you guys say. Should we still try it? Special interacts. Okay, sure, no problem. Yeah, so I'm just going to deploy the contracts. Okay, let's just explain the solidity contract before I move over to that so you don't get lost. So the solidity aspect of it, basically, we have this we have the ERC20 token, which is a replica of our token on StarkNet. But what this ERC20 token basically does is it's deployed with a 0 to tau supply, so there is no supply. We basically use opens of Zeppelin to create a simple ERC20 token. And yeah, so what else is there to know about the token? So if you understand solidity, this should not be very difficult to understand. It's a very basic token. Okay, yeah, sure, no problem. So this is a very basic contract. Basically, we set the bridge contract here in the constructor while we deploy the ERS20 contract. We're going to set the corresponding bridge contract because we are going to be using it as our owner. So basically, the modifier only owner is used for access control. So we're going to use it to make sure that we block access to this for these functions. So just the bridge contracts, basically. So only the bridge contracts can either mint or bond tokens, right? So that has no much issue. So the iStacknet code also, I said, is is an interface that represents darknet core contracts on Ethereum. So for all you inside here, you will find every single function signature that has to do with like messaging. Then we go into the token bridge.so. Now this is the more complex contracts, probably need to explain, right? So what we did here was first one imported the interface, token interface, because we're going to be needing it. And we imported the StarkNet core interface because we're also going to be needing it. So we're going to initialize this, guys. We are going to set the bridge L2 address. So if you notice, we needed to set the bridge L2 address here. So it means we would have to deploy, and if you notice, we did that in the constructor. So this means that we'll have to deploy our Cairo, our StarkNet token bridge first before we deploy this guy, since the address of this is needed for this to work, right? But if you notice in token bridge of Cairo, we can set the bridge L1 address afterwards, as after deployment. So basically we have a modifier only on our access controls, basically where we set the bridge contract and make sure that we require that the message of sender is a bridge contract admin, right? Yeah, so we go into the constructor, we set StarkNet core contracts are going to be supplying the address for the StarkNet core contracts. We're going to be supplying the address for the bridge L2 address contracts, and we're going to be supplying a bridge contract admin address for our Ethereum contracts, our Ethereum bridge contracts. So we move over to set the L1 token. So the ERC20 token is our L1 token. So we are going to set it in here. That's the token we are going to be minting and burning. That's the replica of our StarkNet African token on StarkNet. Then secondly, we have the function withdraw to L2. Now, this particular function, basically, it does something very simple. So it gets the user balance, it creates user balance, then it checks that the user balance is greater than or equal to amount. We want to be sure that the user has the amount he's trying to bridge, right? Then once that is done, like I told you, we are going to be burning and minting on the other end. So we are going to be burning and transferring on the other end. So we are going to burn the amount from the user's wallet, and then we are going to send a payload. Now this is going to slow down a little. So basically we created a payload. Now this payload has it's a three-sided array, right? So this payload now is going to contain three things. So the first placement as first element of payload is the first member of the payload, basically is the L2 user address, right? The payload array. So is the L2 user address. So we are going to send in the L2 user address as the address of the person we want to like transfer the tokens to after burning. Like this user now, he would probably have to supply his L2 address, so that once he burns his L2 tokens or his tokens on L1, we are going to be transferring that same amount of tokens to his L2 user address. So then we have payload 1 and payload 2, which is basically a split of the amount. So like I told you earlier, Cairo just has fields, but Solidity has 256 by default, as you can see. It also has other stuff, address, strings, and the rest. So like coming back here, we have a function, an internal function to split units, which we can use to split the amount into a low and a high value that is required in fields. And don't worry, you don't need to know how to write this. I never wrote this from my head. I copied it out from someone's repo. So you could also copy it yourself, or if you want to try to understand the code, well, that would be great, kudos, but I cannot do so well with explaining to you because I myself do not understand it so well. But basically what happens here is there's the two split units, you supply unit 256 value, and it divides it into two 128 bits, basically 128 plus 128, 256. So the low 128 value, the high value, I think that's the value. Okay, it's not so complex though, but yeah, so the whole idea is divided into two 128. One part is the low, one part is the high. So once we divide that, basically we are going to supply that as our payload 1 and payload 2. Now we are going to send our message to L2 finally. And as you can see here, we are supplying 3 arguments when we call the send message to L2 on the StarkNet core contract. Firstly, you're going to specify the bridge address you are trying to send to. That's super necessary. You need to specify the bridge address you are trying to send to. Secondly, you need to specify the deposit selector. This cannot be overemphasized. So I call this the deposit selector, but basically what this is a function selector. So a function selector basically is like a representation of your function name. Like for example, in this Solidity function, right? Your selector, I think, is the function name with its parameters, the parameters you have set. So this is called a selector. If you hash this, right, probably on Solidity to be catch-256 hash of this, you get the function selector, right? And on StarkNet, same here. Our function selector should be set bridge L1 address, or I think on StarkNet instead function selector is set bridge L1 address. Sorry, not this. The L1, we're going to go into the L1 handler, right, to L2. We're just going to be hashing the function name, and we are going to be using this as our selector, right? But the problem with using just the name as a selector, right, is the fact that you cannot have this name twice in probably in a contract, or you might cause a lot of confusion for your compiler, right? So basically we can call to get the selector from a contract. Just simply copy the name of the function from in the function name, right? Just simply copy the name of the function, then head over to that tool I sent us earlier, utils.tubo.co, right? And I'm just going to paste that here. And you can see the selector, it's this one, it starts with 118 and ends with 818. So let's check if that's the same with our token, what our token bridge has. So this starts with 118 and ends with 818. So this is correct, right? I didn't change the name. This name is same as what I saw for the main implementation. So as you can see here, we already have our deposit selector. And this deposit selector is the way your compiler recognizes the exact function you want to interact with. Because sometimes in your Cairo contracts, you might have more than one function which has this L1 handler. So you need to specify which exact function you want to interact with. If that is confusing, I know I'm a bit fast, so that's because we have just 15 minutes left. So if you have any questions, just ask in the chat and I'll attend to it. Now let's go back to our Solidity contracts, right? So next up, we have, so we send message to L2, right? We supply the bridge L2 address, the bridge we are sending to, the selector of the function, that's the deposit selector, and finally the payload. The payload is what we constructed. So then we have the function deposit to L1. This particular function now consumes a message coming from this particular function consumes a message coming from the layer 2, that's from StarkNet, right? So we have deposits. When we are sending message to L2, we use the send message to L2 function from the interface. When we are consuming message, we use the consume message from L2 function in interface. So basically, well, the consume message from L2 requires the bridge L2 address and the payload, right? So we are now, the way it works is this consume message from L2 now, the way it works is if the payload that you constructed yourself does not match the payload that is sent from does not match the payload that is exactly sent from StarkNet, what happens is you get thrown an error. Now, debugging these contracts, like debugging. All right, sorry about that. I'm just going to start sharing my screen again. It's left because of all right, so the way this works now, the consume message from L2 works on layer 1, right? This particular function is that it's very difficult to debug this because basically this particular function will throw if your constructed payload, that this payload you would construct here, does not match the payload which was supplied, like which it is getting exactly from the layer 2. If it doesn't match the payload, it will throw an error, as in the contract automatically through, and it will not throw an error that is specific as to why it failed. But just know each time it fails is because your payload and the payload coming from this L2 address does not match. So basically, we need to construct a payload that matches the payload that will come from this address, right? So we come here, the memory payload, right? We construct our own payload. The first payload is the caller as unit 256. So we need to get the caller as unit 256. Where did I get that from? Okay. Yeah, so the caller as unit 256 basically is we changed the unit 256 representation. Like we know that address on Solidity, like address is normally, I think it's 160 bits of 160 bytes, right? So we are going to change it from unit 160, right, to unit 256. So changing to a unit 256 variable, right? That's the unit 256 data type. So once we carry out that change, we are going to supply it as the first payload, like the first element of our payload. Now, if you go back to the token bridge.cairo, check the payload, right? You see that the first element is the caller, the second element is the amount.load, the third element is the amount.high. All right, let me just confirm something. All right, yeah, I suspected this was wrong. This was wrong. Now, the reason why this was wrong is because the caller would get from that we will get from StarkNet would not match the user's L1 address, right? So the user L1 address was supposed to have been gotten from the argument which was supplied. So this is supposed to be L1 address rather. I suspected I was wrong. Yeah. So it's supposed to be L1 address rather. Yeah, I suspect that was wrong. So we are going to head back here. And so as you can see, if you change it to unit 256, that should be our first payload. Then the second payload should be the amounts that we are accepting, split into two. We can supply the amounts that we are accepting, right? The expected amount we want to consume as a parameter when we are calling the deposit to L1 function. So once we do that, right, we should have a correct payload. Now we're going to consume this payload. And afterwards, once this doesn't throw any error and StarkNet core contract successfully consumes this message, right, we are going to now mint like an amount equal to the amount, right, the amount that was transferred from StarkNet. We're going to mint it to the message was sent out as the call out the contract. So lastly, we have a getter function for checking the balance of the user, which is simple. You just calls the balance off of the ERC20 token. And we also have the to split unit, right, which is the internal function I talked about. So that's just a breakdown of the Solidity contract. If you don't understand anything, still ask me a question. So to basically interact with to carry out the interaction, right, on the Solidity end, we are going to be using Remix, since Remix automatically generates it means for us to interact with the contract rather than going through the hard things and trying to verify our contract in order to be able to interact with it on Etherscan. So we're just going to head over here on Remix. I'm just going to load it on Remix. Okay, while we do that, right, let's try deploying this guy. So I'm just going to run the protostar build command again. Protostar build. All right, so let's check if Remix has been loaded up. It is taking a longer time, probably because of my slow internet connection. Okay, there's an error. Okay, I made a mistake. That was in the Cairo contract. So we can see here, this is 3S wrong. It's supposed to be 2S. And we're going to come here and Just try building again. Remix, why taking so much time? Hey guys, this has built while we let remix load. I don't know if it's my internet or what, but let's just see. Hope that that comes up. So while we wait for that to come up, we're just going to we are going to now in this case we have two contracts: the bridge ERC20 token and the bridge address, right? So we're going to deploy both tokens, right? So we are seeing going to first start with declaring the ERC20 token. So for that, we're going to just bridge ERC20, bridge ERC20, yep, and we're going to specify the account address on to declare from, which we've done previously. I'm just going to not this. Account address, this guy here, I'm just going to copy him. Yeah, and I'm going to pass that, and network is going to be testnet. Yeah, then max p is going to be auto. So we're going to let that declare. And at the same time, we're also going to try. All right, seems there's an error. What does it say? Couldn't find this dot slash build slash bridge years 20. Did you run protostar build? Yeah, I did. Let's check. What I just typed there. Oh, right, that's wrong. I missed it though, Jason. Yep. So just going to go back and correct that. All right, .json, and I'm going to deploy that. I'm going to try to declare that again. All right, Remix finally decides PTOs and open up. Yeah. So I'm going to just head into the StarkNet messaging folder. Does he have a token bridge? Yeah, it already does. Already does. So I already have a token bridge contract here. I have the ERC20.sol contract, everything we need for this part. So I think the first thing we need to deploy is we'll be needing to deploy the Cairo contract, after which would come here and deploy the I think would come here and deploy the bridge contract on Ethereum. Then lastly and finally would be deploying the ERC20.sol contract on Ethereum. So let's just move on. So it throws an error. It says server disconnected, probably network issue. All right, let's try again. All right, so we finally successfully declared that. So we're just hurriedly going to declare the main bridge contract itself. So we're going to say declare dot slash build slash Mosaic code bridge slash bridge dot JSON. We're just going to declare that. And okay, since they are just the same, I'm just going to simply run this command again and just remove the ERC20 from there, rather than try to like get all those stuff differently. So I'm just going to move in and clear the ERC20 from that and try to declare that. All right, so I'm just going to move in here, clear this guy, and yeah, let's declare this guy. So while we declare, let's check that this guy has already been successfully declared. So we're going to head over to StackScan, and I'm going to just search this class hash. All right, tell me you have been declared. Not yet. Let's see what's the issue. Let's head over and check out the transaction hash. Let's just check it. Okay. This is so the bridge. Let's check the transaction hash. Oh, testnet 2, wrong. Here. All right, let's check the class hash once again. I was on the wrong network initially. This is the bridge ERS20.json. Let's check the class hash. Okay, that shows up. Let's check the second guy here, the bridge. Let's check if it's up already. Not yet. Let's confirm that the transaction did not fail. All right, transaction did not fail. It's just taking a lot more time. Well, then we are going to deploy our ERS20 contracts first. We're just going to run proposal deploy. I'm going to copy our class hash, and that's for this guy. I'm going to copy the class hash. Yep, and proposal deploy. This the inputs. Basically, we have we're just going to go into our utils.2. Okay. Yeah, trying to find something. Sorry, just move here. Yeah, I'm going to come here and I'm going to choose get StarkNet Africa. Yeah, I'm going to copy the field representation, paste that. Then for this, I'm just going to copy stack. Copy this, paste this, name symbol, decimals, total supply. Then I think the last is Una, so I'm just going to get this guy. And then we're going to pass in the account address. Then we're going to pass in our network, testnet, our max fee, auto, and this should be deployed successfully. All right, so while we wait for that to deploy, we're going to go ahead to deploy the bridge contract itself. So the class hash is for the bridge contract is this. So I'm going to copy the class hash. We'll start deploy this. Then the inputs, it takes in what? It takes in the L2 address and the admin address, the L2 address and the admin address. So the L2 address, we already got it here. This is the L2 address from what we just deployed. It's this guy. Okay, that's the L2 address. Then our admin address is just going to be my account. And I'm going to supply the network, which is testnet, and the max fee, which is auto, and the account address, which is still my account. Well, let's deploy that too. Well, that gives an error. Invalid transaction nonce. Expected 40, got 39. Okay. Maybe we should wait a bit for this guy to get deployed. Let me confirm that that's not where the error is coming from. So we are out of time already. All right, so we're just going to let's check if the first contract has been deployed. Yes, it has. Let's just read to confirm. Yeah, it has. So let's try deploying a second once again. And I'm going to just I'm going to keep this guy. We'll not do this guy. I'm going to open another testnet.startscan.school, testnet.startscan.school here. And we're going to be playing around with the bridge address. Okay, we finally have the bridge address deployed, which will take a while. So this, we've now got the bridge address, right? The bridge address, yeah, the bridge address is here, this contract address. So we are going to use this guy to deploy it. That is necessary for deploying our token bridge or so. So we are going to head over to our compiler first, select, okay, this is correct. So we are going to compile token bridge.so, which is the first contract we need to deploy. And we are going to head over here, and we want to deploy to injected provider MetaMask, right? Okay. Let me be sure I'm connected to Coeli. Yep. So okay, I'm going to deploy from this guy here, enter an amount. Okay, that was not necessary. So this StarkNet core address. To get StarkNet core address, we're just simply going to head to testnet.starkscan.co once again, but on testnet this time around. And you're going to go to developer address book. The core contract is this. We're going to be using this. So I'm going to head back to Remix, and our core contract is that. Our bridge L2 address is this guy. Let me be sure he's loaded up. Let me be sure he's loaded up. So we're just going to go in here and search for him. Yeah, it's loaded up. So right contract here. So I'm going to go back here, and I'm going to paste it here. And our bridge contract admin basically is going to be my MetaMask address. So I'm just going to use this guy. Yeah, and I'm going to transact. And I'm going to confirm. Okay, so we should have that deployed in a matter of minutes. Okay. I'll wait for that to deploy. The last thing we're going to deploy after deploying the bridge will be the ERS20 contract. So, but let's wait for our bridge contract on Ethereum to be deployed first. Okay, just keep coming back here to ensure we are all following and probably not the only one correctly in the code. Okay, so here we deployed our bridge. This is our bridge contracts. As you can see, this is it. So we are going to copy the bridge contract, and we are going to next up try deploying our ERS20.so. This is our ERS20.so. I'm going to go ahead and compile our contracts, go over here and try deploying our contract. So it just needs the bridge contract on L1, which is this, and we're going to transact. Yep, confirm. And we're going to wait for that to be deployed because we're going to need to set our L1 token. So while that is done, the first thing we need to do is we're going to need to test. We're going to need to go from L2 to L1 because this, I think, how many total supply did we mean for? It's simple. Let's just go over here, read, not this guy. Let's go over here and read the total supply, right? So if you query, we can see our total supply is 1,000. So we have 1,000 tokens here, but on Ethereum, like I said, we'll be deploying the zero total supply. So if you come over here to read from this guy, if you read the total supply here, you should get 0, right? Yeah, 0. So we cannot go from L1 to L2 without going first from L2 to L1. So to go from L2 to L1, the first thing we need to do is we need to come to write contracts, and we're going to need to set our L1 bridge address. So to set our L1 bridge address, we're going to go back to Ethereum, that's to Remix, and we're going to copy our bridge address. This is our bridge, right? So we're going to copy it, and we're going to come here and we're going to set our bridge address. All right. So we're going to write, okay. All right, then review transactions. I'm going to approve. Yep. And okay, so we're going to wait for that to go through before we try withdrawing to L1. This is where the phone starts, because if anything goes wrong, things are not going to work as planned. Well, okay, this is taking longer than okay. So while like I said earlier, L2 to L1 transactions take a L2 to L1 transactions take quite a while, right? Yeah, L2 to L1 transactions take quite a while. Like I said, 8 to 10 minutes probably. So while it might even exceed to 15 minutes, depending on how the network is. So, but while we do that, we'll probably go try out the upgradable contracts, and then we'll come back to check if things worked as expected. So we're going to go to withdraw to L1. Now you see you're going to see the beauty of StarkScan soon, because StarkScan helps a lot with tracking our L2 to L1 messaging. Like, it helps to track it effectively. So we're going to go to withdraw to L1 basically, and we are going to put the amount we want to withdraw. So let's say we have just let me confirm something. If you come here, you would see that under withdraw to L1, right? Withdraw to L1, we need to call the transfer from function, where we need to allow this contract. So we are going to probably need to approve first. There's a question. Does it take so much time and minutes? If yes, why? Yeah, it does take quite a lot of time. The reason is because okay, this is the reason, right? Moving from settling like a lot of money, like a lot of money is spent when trying to like call data. Like I think earlier in our fixed call, we said that roll-ups basically bundle, like ZK roll-ups, what they do, right, is they bundle different transactions together with their proofs, right? And they post it on Ethereum as call data. Now that call data is actually very expensive, and the beauty of roll-ups lies in the fact that a lot of transactions are bundled and posted at once. So in a case where like a lot of transactions are not bundled before posting on like L1, it's not a very cost effective idea, right? So imagine posting every transaction, or probably every 10 transactions. Probably if you're supposed to bundle 100, and then you can only bundle 10, and then you are paying the same gas fees you are supposed to like pay for bundling 100. So it doesn't make sense. So because of that, the sequencer have to like accept a lot of transactions, probably reach like a transaction, like probably reach a threshold of rolled up transactions, right, before posting to L1. And that's why L2 to L1 messaging usually takes time. I don't know if you actually understand that, or if you don't. All right, sure. Then so we need to approve our bridge address. We need to approve our bridge contract address from this ERC20 to spend from our ERC20 token. So we're going to go to write contract, connect to wallet, and we're going to call the approve function. The spender is a bridge contract address, and the amount I'm going to approve it to spend the 100 tokens. So right, let me just make it 50. All right. Okay. So, okay, let's just make it 100. Easier to do calculations now. So I'm just going to approve this guy. Yeah. Let's wait for that approve to go through. So once the approve goes through, we're going to come back here to try to set our bridge L1 address. Our bridge L1 address. So the last contract we actually supposed to go through is the upgradable contract. But I'm currently so tired. that I would probably not be able to write that from scratch. But what's going to happen is I'm going to try to explain it to the best of my my knowledge. I'm going to try to like explain to the point where you can understand how to implement one. And the repo, like the comments are very detailed. So with my explanation, you should be able to implement this stuff, but writing it from scratch at this point, my strength may fail me. And yeah, and it's already 7:13 when I've been on for about 3 hours, 13 minutes. So yeah. So basically, okay, this is gone. So let's go back and just initiate that long process. So I'm going to go to withdraw to L1, and I'm going to try withdrawing 30 tokens. Okay. The L1 address I want to withdraw to is my beautiful MetaMask address. I'm just going to copy this guy. I'm going to paste it here. I'm going to write. All right. Yep, I'm going to approve the transaction, and then we are going to track that transaction. So we're going to open it up in another tab, and while that loads up, as you can see here, the transaction is still yet to be accepted on L2 and it's still far from accepting on L1. But there's a place where once it's accepted on L2, I think there's a point from which we can probably track the messaging. But let it get accepted on L2 first. We'll be back shortly. So let's go over to like check out the upgradable contracts. So if you have a good Solidity background, you should have probably heard of upgradability. Upgradability is a very necessary important concept in smart contracts, because we know smart contracts are immutable. That's like their golden selling points, but it can also be their biggest weakness, because imagine you wrote a buggy contract and you deploy the contract, and it's a contract that is set to handle millions of dollars. You get not being able to upgrade the contracts can lead to very big disadvantages, like can really cost a lot to get. So being able to upgrade contracts is like a very beautiful feature that a lot of protocols tend to implement. So the whole idea behind upgradable contracts is you have what we call a proxy contract. Now, the proxy contract is the contract which serves as the entry point to your contracts, and it also holds the contract storage. So the think of the proxy as the memory of your contracts. Basically, it holds the storage, everything that has to do with the storage, it holds it. Then your implementation contracts are the contracts that contains the logic. So you abstract your logic into what we call an implementation contract. Now, this implementation contract is what can be swapped for another contract if you are trying to upgrade your contract. Now, for a deeper dive into this, right, there's this article by David Barreto. You could check out the repo, the link on the repo, right? So basically, in this particular exercise, we are supposed to learn how to build upgradable contracts. And it's actually very, you are building a contract, or you have a protocol that already exists on the mainnet, right? You need to understand how upgradability works, because with Genesis at hand, it will be impossible to upgrade your contracts to it will become possible. It won't be possible. It will be impossible to version 1.0 if you don't understand how upgradable contracts work. So yeah, so thanks to the team at Open Zeppelin, we did was we copied the proxy contract that is already that you can find in the Open Zeppelin repo. Follow the link here. We're going to copy it into our own repo. Now let's look at the proxy contract. But before then, let's go back to our messaging. So as you can see, it's accepted on L2. And as it got accepted on L2, a message has been logged, right? Now, this message is what we're going to track. So as you can see, this is the beauty of StackScan. It shows you your message hash. You can see the direction from L2 to L1, right? And the type was sent on L2. Now we're going to go into the message. I think the message hash, let's check out the message. As you can see here, it's currently sent on L2. So So it needs to be attached on L1 and finally consumed on. So these are the three processes in sending the message. You send the message gets attached on L1 and finally gets consumed on L1. So attaching on L1 is when it gets attached on L1, it means it has arrived on L1. And at that point, that's when we can do stuff with it. Then consumed on L1 means like it has been consumed. So probably means we've called our deposit to L1 function or something. So we're just going to wait for that, right? While we wait for that, let's go back to our upgradable contracts. So we're going to just, if you head into the repo, right, right, into min upgradability, go into the proxy.cairo. I'm just going to close this guy. Thank you, you've tried. Yep, and as you can see here, this contract that you can see here was not, it was not handwritten by me. And you might probably not even need to handwrite it yourself, except you want to probably add some features. But then this is a good proxy contract. This was created by the team at Open Zeppelin. So basically what it does is we import the proxy namespace from the library, and you have the constructor. In the constructor, when you are deploying your proxy contract, you need to set the implementation hash. The implementation hash is like, okay, this is something I also need to explain also. Now, in upgradable contracts, the way upgradable contracts work in Cairo, right? You do not deploy your implementations. That's the contract which holds your protocol logic, right? You don't deploy it to StarkNet, you just declare it. Now, I think in our last two classes, right, we properly differentiated between what a declaration is and a deployment is. So I said declaration just creates a class hash, right? A class hash is like a hash of your contract code, but a deployment creates a contract instance. So when you are creating upgradable logics, you do not deploy your implementation contracts, you only declare them. Okay, I can see a question. Do we have concepts like EIPs in StarkNet? Basically, StarkNet inherits the EIPs existing on Ethereum. But if you want to find, if you're talking about common standards they're trying to establish in Cairo, you can find that in head over to StarkNet community forum. Let me find the link, StarkNet community forum. So this is where changes to StarkNet proposals are usually created. But then most of the EIPs that exist in Ethereum, the ones that can be accepted on StarkNet, are usually like inherited. But the community, the StarkNet community forum is a place where changes are proposed and builders discuss on it before it is finally implemented. Like, for example, the universal deployer contract on the community forum. So you could check that out. And yeah, so let's ride on. This is 7:21. Let's ensure we finish before 8 o'clock. That'll be 4 hours of learning in Cairo. Okay, that's a lot. Yep. So basically the proxy contracts contain some important functions we need to understand. So firstly is the constructor. The constructor takes in 4 parameters. We have the implementation hash. Like I said, implementation hash is the hash of our implementation contract. So we don't deploy this, we only declare it. Then we have the selector. The selector is the function selector, or the hash of the initializer function in our implementation. So our implementation does not contain the constructor. Remember that the proxy contract is our entry point. So our implementation cannot contain a constructor. Instead, it contains what we call an initializer. Let's check out an implementation. An example of an implementation is the implementation version 0.cairo, right? So I'm just going to do something here. Oh, this only appears as a namespace, no point. So let's just go into the proxy.cairo, right? So this is selector this will most times be initializer, right? The function name is going to be initializer most times. That's the standard. They are going to pass in the call data length. The call data length is the length of your constructor array. And then the call data is your constructor parameters or arguments. Now, the next thing we're going to do is Open Zeppelin. Basically, if you want to understand this, you can just check out Open Zeppelin's repo. But what we exactly do here is we set the implementation hash. So when you set the implementation hash, this implementation hash becomes the contract that Open Zeppelin forwards incoming calls, read and write to. So basically what happens here is we check that the selector is not 0. So if the selector is not 0, we'll make a library call to that particular function selector and in the implementation hash, that's the contract. So library calls are a way to interact with declared contracts that are not deployed. So using StarkNet's library call, you can interact with contracts that are declared but they are not deployed. Else you can't interact with undeployed contracts because they have no contract instance. So next up we have the default. So basically this default is should I say, think of it as a callback function. There's what we call a callback function, right? So basically what this does is each time the proxy contract gets a selector that it doesn't recognize, it automatically forwards it to this function, the default function. Now, these decorators might be new to you. The @raw input tells this function, tells the compiler that basically this function you are going to return. I want you to take in the inputs without passing. There's what we call passing, right? Compilers pass your inputs into like proper arguments. We're just telling the compiler, I don't want you to pass this argument. Same thing for the raw output. You're telling, give me the raw outputs, the return data size and the return data. Don't try to pass it to me. So this L1 default does same thing as default, just that it handles all calls coming from Ethereum. That's layer 1. It handles all calls coming from a layer 1. So that's just basically what you need to understand about the proxy contracts. I didn't write that myself, and most times you don't need to write that yourself. So if you want to check out that, just head over to Open Zeppelin, Cairo contracts, and you'll probably find it somewhere. Cairo contracts, source Open Zeppelin, check out upgrades.
I'm sorry.
Okay. Yeah.
In the contract just closed now, I'm seeing like multiple decorators being placed before a function, right?
Yeah.
My question is, are they acting as like modifiers now here or what? Like,
yeah, they are basically decorators, but this time around, the external decorator, we know what it does, right? It tells the compiler this is an external function. It should be able to interact with it. Then we have the raw input. That's what I just explained now. The raw input decorator basically tells the compiler that the input arguments I'm going to be passing to this function, I don't want you to pass it. By pass, I mean this pass, P-A-R-S-E. I don't want you to pass that arguments, those parameters, right? Just supply it to like my function just the way you get it. Don't do anything with it. Don't work on it on any way. Same thing as the @raw output. We are telling the compiler to the return argument you get, just return it that way. Don't play with it. Don't do anything with it. I don't know if you get.
yes, thank you.
Yeah, sure. So if you want to understand more on the proxy contract, you can check presets, the proxy.cairo. Yeah, and that is just a simple example of a proxy.cairo. This is still not attached on L1. So let's just continue. So the next thing we need to look at, we'll be looking at how to create an implementation contract, but I'm not going to be coding this from scratch as we did others. So basically, we then move on to creating our implementation contracts. We add key functions like upgrade, which is responsible for upgrading the implementation, like set admin, which is responsible for setting a proxy admin. We add other key function, get implementation hash, which is responsible for getting the implementation contract we add the last function get admin, which can be used to get the current proxy admin. So some important things you should note that the implementation contract should never be deployed like a regular contract. Instead, the implementation contract should be declared. That's one. Two, you should never set the initial state with the traditional constructor. That you should never, your implementation contract should never have the at constructor decorator or a function that implements the constructor, right? Instead, you're going to use an initializer method. Now let's look at the implementation contract. Let's see how that looks. All right, so we are going to head into the upgradability folder, and we are going to head into the proxy.cairo, okay, implementation, sorry. Now, this is the version 0. The version 0 was the first implementation that probably was deployed with the proxy contract. So that's why it was named version 0. So as you can see, we use an initializer instead of a constructor. So this initializer is what initialized. So in this, our implementation version 0 is a simple ERC20 contract, basically. So we just initialize the name of the ERC20 contract and do other stuff we do in ERC20 contract. So it's a simple ERC20 contract, but basically it just have some other new functions added. I call them proxy related functions. So it has an upgrade, it has a set admin, it has a get implementation hash, and it has a get admin. So it has so those are 4 new functions that we are added. So the upgrade contract basically, first of all, checks that the person trying to upgrade is an admin. That's the first thing. Then secondly, it sets the new implementation hash. Now the next part is this guy here. So what happens here is we set admin. The set admin basically first of all checks that this function is the person trying to call the function is an admin. Then secondly, it sets a new admin. Then the get implementation hash basically it calls the get implementation hash internal function, and you get returned the implementation hash. Then lastly, we have the get admin for getting the contract admin. And now the implementation version 1 does something more unique. Basically, we decided, okay, I don't want a normal ERC20 contract, right? I want to improve my ERC20 contract. So if you notice, this new ERC20 contract has some new functions added. So I upgraded the functionalities, adding a bond functionality. I added the transfer ownership functionality. I added a renounce ownership functionality. I added a mint functionality. I added an owner functionality, right? So this is an upgraded function. Remember, it will still have that proxy related functions. Compulsory always has it, except you decide, okay, this is the last implementation, I don't want to upgrade it. Anytime you remove these proxy related functions, you know you're not going to be upgrading your contracts anymore. So that's about it. And well, we're not going to write this out, man. We've done a lot. We've been learning for the past 3 hours, 30 minutes. Let me see if our stuff has still not attached on L2. Well, let's try interacting with the upgradability contracts on testnet 2, because when I built this repo, I built it using testnet 2. So heading over to testnet 2, we're going to go here and check. All right.
Deploying this upgradable contract, is it the same as the normal ones we write?
Oh, okay. It's the same thing. Okay, you know what? Let's just deploy it. So
yes, let's deploy them, we interact.
Yeah, let's just do that.
Thank you.
Right. See you. Yeah, sure. You're welcome. I'm just so tired by this aching, but yeah, let's do this. We signed up for it. All right. So the implementation version 0, we're just going to copy it, right? We're going to copy it, head over to our repo, and just paste it in our implementation. So in our implementation, let's create a new file, call it implementation v0.cairo, and in here I'm going to paste this and I'm going to save it. And I'm going to create our version 1 implementation v1.cairo, and I'm going to copy the implementation contract. Yep, I'm going to copy this guy and paste and save. Yep. So we're going to head over to protostar.toml and let's try let's try deploying this. Let's just clear this. This is clunky. So let's start with building. Protostar build. All right. So all right, this is taking a longer time than anticipated. Let's just wait. All right, this is successfully compiled. We're just going to head over to declare the, let's start with declaring, we're going to declare the two implementations first. So firstly, we're going to declare /build/implementation v0.cairo, so .json instead, .json, and our account address, we're just going to get that from agents once again. Let's get this guy from agents. The network, our network is testnet, and our max fee is auto. So let's declare this. So remember I said the implementation contracts are declared but not deployed. So the only contracts we're going to be deploying is our proxy contract. So let's start with the first, that's declaring. All right, so next up, we are going to declare the V1. So basically, that the same thing, just the change in the version name. So I'm going to change that to implementation v1.json instead of v0.json. And we're going to declare that too. So v1.json. Okay, so yeah, let's declare some. You know, well, let's check out our wow, this is taking a lot of time, still not attached on L1. Let me reload to be sure. What connects the implementation to the proxy? Like, how do they interact? Okay, that's a valid question. All right, so this is how the proxy and the implementation contract interacts. Declare and deploy my proxy contract, and I'll explain that to you. Declare, protostar declare. All right. I forgot to uncomment my proxy contract. So I have to comment that and rebuild again. So we're going to start with protostar build so we can get the class, we can get the build file for the proxy contract too. Okay, so while we do that, this is the way it works. Basically, this is the whole logic. Let me see if I can use, okay. So this proxy contract is called the entry point for your protocol. That's your protocol contract, right? So basically, when you are going to be deploying this proxy contract, you're going to be supplying the implementation hash. That is the contract that holds your contract logic. This implementation hash holds your contract logic. The proxy contract holds your contract storage. Always note of this: proxy contract, contract storage, implementation contract holds your implementation, your contract logic. Now, this is what happens each time your proxy contract gets a call or gets a request. Each time you request a function that does not exist on this proxy contract, like for example, as you can see here, the function selectors that exist in this proxy contract are just the L1 default, the default, and the constructor. So each time it gets a call that doesn't exist here, there's not any of this, right? It checks two things. One, is this call coming from StarkNet? Is it coming from StarkNet? If it's coming from StarkNet, you know it won't have the @L1 handler. But if it's coming from layer 1, you have to add this. It's going to need this L1 handler to interact with it. So if it's coming from StarkNet, basically it's going to be passed inside here, and once it's passed inside here, a library call is made to that particular logic, like the declared class hash. So the declared class hash, okay, this is built, sorry. Okay, let's just continue so I don't get confused. So the declared class hash can only be interacted with using a library call. Like I said earlier, a contract you don't deploy has no instance. So the only way to interact with it is through from the StarkNet Cairo lang library, right? So using the library call, you are going to supply the class hash. That's the implementation contract you want to interact with. The function selector is the selector that you are trying to interact with. The call data size is the whatever parameters you are supplying. That's the call data size and the call data. Now, anytime it gets it would supply all these things to the underlying implementation logic. And then once the implementation logic carries out whatever logic that exists in the implementation, right, it now vomits back everything, like the return, the things that it got from carrying out its logic. It vomits it back to the proxy contract. Now, if there's a change of state to be made, that change of state will be made on this proxy contract, because this proxy contract is the main contract. This is what holds the contract storage. I think to better understand how this works behind the scene, you'd probably have to study like the library, the proxy library, because that was what I did basically. Try to study the proxy library, probably write it out by yourself. But the whole idea is proxy holds the storage, implementation holds the logic. Implementation is a declared contract, so it doesn't have an instance. So nobody can interact with the implementation directly. You must have to go through the proxy. So the proxy is the face of the implementation, and if it doesn't exist in it, it goes over to the implementation. The implementation carries out the logic. Once it carries out the logic, it vomits it back to the proxy, and the proxy changes the storage or does whatever that's necessary. I don't know if that answers your question, Sisi.
That's kind of I don't know, it's not so clear, but maybe when I read what you said I should read, I'll have a better understanding.
Yeah, sure. You could also send me a message on Telegram too. I know I'm very slow at replying messages, but yeah, just try. I'll try to like. Well, okay, better still ask in the group chat. I think if you ask in the group chat, it's easier to reply than privately. But anyhow, just reach out to me on Telegram if you don't understand this. I need us done by 8 o'clock, please.
All right.
All right. Yeah. You guys have stayed a whole lot. Guys are probably tried. Okay, so let's try let's move over to declaring the proxy contract. So I'm just going to run declare.build slash proxy.json. And I'm going to supply the account address, which is this guy. And I'm going to supply the network, which is testnet. And I'm going to supply the max fee, which is auto. So once this is declared, we are going to just head over to deploying it. And we're going to try to interact it with it. Maybe in the course of interaction, you probably like get more clarity. We'll start to deploy. We're deploying the proxy contract, remember, so we're going to deploy it. All right. And we're going to pass in our input. Like I said earlier, the first input will be passing in, as you can see here, is our implementation hash. Now, our implementation hash we're going to pass in is the V0. So the V0 is the normal ERC20. So when I declared that V0, this was the class hash. So I'm just going to pass that guy in here. Then the function, the constructor-like function on our implementation logic, that's the selector of the constructor-like function, is the initializer. So we are just going to change initializer to like selector format. So I'm just going to come here and say initializer, selector format, and selector format is this. I'm going to copy this, and it's going to be our second input. And the third input is the call data len. So if you check our implementation logic, how many call data does it take in? It just takes in the proxy admin, just one. So I'm just going to pass in one. And the proxy admin it takes in, that's the last one. The last argument is the call data failed. So okay, the call data is going to be the admin. So the admin is going to be my wallet. So I'm just going to come here and copy my wallet address, and I'm going to come here and paste it. Now I'm going to put in the account address I'll be deploying from, and I'm going to put in my network, and I'm going to put in my max fee. All right. If everything goes well, we should have our proxy contract deployed and ready to be interacted with. Perfect. So our proxy contract has been deployed. So we're going to give it a while, then we're going to try interacting with it. So I'm just patiently waiting for this guy to go up. But as you can see, it's even taking more than 8 to 10 minutes I told you about. I think it's almost close to 20 minutes already. Yeah, so oh, finally it has been attached on L1. Yeah, so let's go back, and before we try interacting with our proxy contract, right, let's complete it with what we started with, the messaging bridge. So we're going to go to remix now, and now we want to have we set L1 at L1 token? I don't think we've done that. That's the first thing we need to do. We need to set the L1 token address. So I'm going to come here and I'm going to paste our L1 token address, and I'm going to transact with it. Yep. So we're going to wait for that to happen. And once that happens, right, once that transaction is successful, we're now going to call the bridge, the deposit to L1. That's this. I'm going to call it deposit. Okay, that's successful now. So let's just come to bridge contract deposit. Okay, let me confirm that bridge L2 was set. Okay, bridge contract admin. All right, deposit selector. All right, so now we are going to, if you check before we consume, right, we want to check that user's balance. Want to confirm the user's balance. At the moment, it's supposed to be 0, but let's confirm. We're going to copy and we're going to paste. So if you call my balance, you should get 0, right? We got 0. So we are going to go into deposit to L2 now. And the amount we deposited, can someone remind me the amount deposited? That was 30, right? So I'm going to put in 30 there, and I'm going to transact with it. All right, we get an error, gas estimation error with the following message. Well, cancel transaction. It appears we had issues. There's a bug in our contract. That error arises because it's not able to consume, like it's not able to consume the message, and we do not have enough time to deploy that. So what? Okay, to probably, okay, what's going to happen is, right, let's compare side by side and see what we missed. So let's go back to the token bridge, right? And I'm going to just put it side by side with the one I wrote from earlier, and no, we're in a hurry, so let me see what exactly we did miss. So going to source, going to messaging bridge, going to L2, going to token bridge.cairo. Let's see if we didn't miss anything. All right, so percentage lang, okay, just ignore that. That's not the what we're looking for exactly. We're looking for the logic implementation. So let's start with setBridge.l, setBridge on address. All right, setBridge on address. We checked, okay, that this function can be called by contract min. Yep, we did that correctly. Then let's check withdraw to L1. That's where the cocoa is. So withdraw to L1, basically alloc locales. Okay, let's call is equals to get call address. We get all this, right? L1 bridge address. Oh, wow, 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 wow. This is where the error is. This is actually where the error is. This address here, this is where the error is. This address is actually supposed to be our bridge address. That's where we are sending the message to, not the address of our account on layer 1. So what we are going to just do is this is supposed to be L1 bridge address, but I was actually typing so fast I actually missed that. And to get that, we have to get that by doing let's L1 bridge address, right, be equal to like bridge L1 address dot read. Yep, and that should have solved our issue. Well, as you can see, we made a mistake, and we definitely cannot try deploying this again, going through that long process and waiting for close to 30 minutes. We don't have such time. So I would encourage you to try this out yourself. Like, don't miss to try this out yourself. That's basically how you learn. You've seen the mistakes we made, try to correct it yourself. Although the repo is actually correct, everything in the repo, I personally built it and tested it multiple times, so I can assure you like everything contained in the repo is correct. So just ensure to go through it and try to do stuff yourself. Yeah, try to do stuff yourself. All right, so we are still here. You guys are really trying. It's a lot. All right, let's try. The last thing we are going to do is we're going to just try interacting with our upgradable contract, right? This is the contract address. So we're just going to head over to testnet. Let's switch to testnet. All right, and over here we're going to search for that address as the address of our proxy, and you can see how a proxy contract looks like. So if you go to write contract, you can see we have the proxy address and we have the implementation. So as you can see here, what we interact with is the implement is as you can see, this does just the function the proxy takes up. This is the implementation is what like we'll be interacting with, right? This is what contains the logic. The proxy holds the state. So first thing we need to do now, for example, if you connect to wallets, you'll be able to like carry out basic ERC20 transactions. If you come here, you can see on the implementation contract, we have access to the name, Now, all these things do not exist in the proxy, but you see, you can access them on the implementation contracts, right? So all these stuff, like this is a normal, if you click on get implementation hash, you should get the implementation hash as the class hash of our implementation v0. And if you click on get admin, you should get my address, which ends with 4976 here. So the next thing we're going to do now, this is how you upgrade a contract. This is how you upgrade an upgradable contract. So you connect to the wallet, click on upgrade, supply your new implementation. Now we declared two implementation earlier, right? Let me find them. Implementation v0, implementation v1. So let's upgrade to implementation v1. So this is the class hash of implementation v1. Now we are going to go right here. This is our new implementation. Now you can see that this has just basic functions: transfer from approved, increase allowance, decrease allowance. But once we upgrade to a contract that has more functions like means, born, etc. So we are going to write new implementation. Once upgrade our this, we are upgrading our contract now. We're going to approve this transaction. I'm going to approve this transaction. All right, so we're going to just wait for that to load up. This is 7:53, and we are going to be rounding up like definitely in the next few minutes. So that is loaded up. So having upgraded our contract now look at the magic. We're not going to be changing our contract address, but once we reload this our browser now, you would see those new functions added. So let's just reload. All right. Okay. What went wrong? Reading and writing contracts. Okay. Let me just search for the proxy contract. Let me be sure what I'm seeing. Proxy contract. Okay. This is a proxy contract. I'm going to just search for that. Oh my God, I made a mistake. When I tried upgrading, I didn't use the right class hash. I used the class hash for the proxy instead of, oh my God. I used the class hash for the proxy instead of the class hash for the V1 implementation. Now you can see that because of that, we don't have access to upgrade this contract anymore. So we're just going to try deploying our proxy once again. And so we're going to try deploying our proxy once again. I just need to show you exactly how you upgrade a contract, all the silly mistakes. All right. So let me just track the implementation v1 myself. Implementation v1. This is the class hash BAG94. Implementation v1 BAG94, right? So let's check out. I don't think this guy must have been deployed yet, but let's check it out. Not deployed yet, so we'll just wait for a while. All right, let's check if it yet. Come on, come on, come on, come on, come on. No, I'll just head up in this. Let's try open it. It seems something went wrong with my connection. Can you guys still hear me?
Yeah.
Yes, but it's shaky sometimes though.
Hello, Sissy, can you hear me?
Yeah.
Yes.
Yeah, man. But then it's kind of shaky, just like you said.
Yes,
Sometimes.
sometimes it's shaky. Yeah.
Oh, well, all right. Well, network issue just began once again. Seeing if disconnecting works. But this is basically, even the sites went here, I'm sure already learned a lot, but I need to how this works. Probably have more clarity. All right. Okay, this has opened, so let's just use this. Yeah, so going back to write contract, right? Connect to wallet. Now let's try upgrading once again. So let me be careful to pick the right contract. BAD94 implementation V1. Yep, implementation V1 declare transaction was set BAD94. Yeah, so we're just going to copy this and head over here. We're going to like upgrade, passing this and write, and let's approve this and wait. Hopefully we should have this upgraded, successfully upgraded, and once that is done, we'll call it a day. But yeah, I hope we learned something today. I can see we have already like decreased so well, just 4% present. I don't know if anybody has any question. So while we wait for our transaction to go through, I could probably sort that out. Yeah, it's 8 o'clock already. We should be
I
leaving.
think personally, I will have to like try doing this thing before I would then have to, ask my questions.
Yeah,
Because there'll be questions actually.
Yeah, sure.
Yes.
Just try doing it yourself and also try to like rewatch the video once again, like because some stuff I actually did, some stuff I actually said was super fast and it have been difficult to pick at once. But if you can go through this again, you definitely like pick it. This still having this issue. Let me check my implementation V1. Let me be sure. Implementation V1 looks correct. So what's wrong? Protostar.ml.
Can you hear me?
Yeah, I can hear you. I can hear you. All right.
Now the
Okay.
deployment.
You said that? I can't hear you. You said that?
The class hash of the implementation.
Sorry, it's cracking too badly. Could you probably just use the chat
Right.
instead? I can't hear you. Like the stuff is breaking up.
When you pass it in, like, is it at the point when?
Sorry, I still can't hear you. Can you just use the chat? I think it's better. So exactly, this was supposed to be the upgraded version, but something seems to be wrong. Something I can't place. You know what? Where I'm going to start debugging this is, let's copy this and check what it looks like. Firstly, let's check the content of this class hash. Oh wow. Sorry about that. That's the issue we had. The issue we had was we're trying to upgrade a contract that basically did not exist. So if we check the transaction hash, we'll see that this was rejected due to invalid transaction nonce. So we're trying to update update to a contract which did not exist, and that was the reason why we kept getting that. Well, just make sure that's one of the reasons. That's if why you noticed anytime I declare my contract, I try to like go to StackScan to confirm that it was really declared, because if you try to deploy a declared class hash that was not declared, or you try to upgrade the class hash that was not declared, it always leads to like very severe complications that might probably take you a lot of time to debug. But guys, went here. Just follow the repo, follow the instructions. Always ensure that your class hashes are declared, and you definitely like be able to like do something correctly. I'm so tired. All right, so let's see this question. The class hash of the implementation is passed at the stage of deploying the proxy contract, right? Yeah, exactly. The class hash of the first implementation is passed at the stage of deploying the proxy contract. Yeah. All right. Any last question before we go? Because we'll be leaving now. We've been talking. We've stretched the class for 4 hours, and I think this has to be the max limit. All right. So I think this brings us to the end of the Min-StarkNet build. Well, I believe that if you attended the class from like the first day, right, you should have been able to like learn and pick a lot, and you can see the frivolities that are involved with like building out basically like a smart contract, right? It's not something like you have the logic and you just write everything and it just appears. You see, we test, we try, we debug, and we try. Yeah, it's been quite an evening, like a very long one. Yeah, thank you so much, guys, for staying around. I would advise that you check out the video once again, and those places where we actually had issues, just try solving them yourself, solving them on your own, right? Like I said, the repo, everything in the repo works, right? I tested everything myself, like time and time again. So definitely like try to reference the repo as you work. And yep, cheers to like building more amazing applications, decentralized applications on StarkNet. Yeah, thank you so much, guys. Yeah, over to you, Paul.
Yeah, I mean, this is actually the longest class like we have had. So I'm just thinking if I would like go through the class, and on YouTube, I would set a timestamp for each section. I mean, did you I think that would be like very better, so people like can just, because it's kind of
Yeah,
like
yeah. That makes sense. That makes sense. Yeah.
I'm going to look through and make it that way. By the way, it's actually like a very, like I said, when I grow up, I want to be like you, man. I mean, the whole class is like so awesome. And
Thank
yeah,
you, man.
yeah, I guess this might be the last stuff for January till the Nairobi boot camp or something.
Yeah, definitely. Yeah, definitely.
Yeah, so we can like prepare for it. And Victor, I mean, you sticking around to the end, is actually awesome.
Yeah, it's a lot actually. It's
Yeah,
what it is, but it's another thing to sit and learn. Oh, yeah, Victor,
actually,
because yeah, thanks
actually,
again for sticking around. And
yeah, yeah. Well,
Yeah,
we are
thank
looking
you,
forward to.
bro.
Seems like Victor's network is quite so bad.
Yeah, the network is actually bad. But then either way, Victor, man, I mean, we are looking forward to like
Alright.
having you as part of the tutors for the Nairobi bootcamp, right? So
Nairobi.
yeah.
Yes. Before then, I'll be very, very much ready. Yeah.
Yeah, sure. I mean, it's just this end of February though, but then yeah, there's still like time.
Of
So
course.
the whole concept is to get every developer ready. I just hope that I'm actually a developer though, but then either way. Yeah, so it definitely, if you have any question, like, you can just drop in the group. I mean, dropping questions in the group actually helps for others to learn. You understand?
Yeah.
So
Okay.
actually,
Okay.
yeah. So even from there, probably you might learn more. I mean, I guess so. But either way, before I will drop updates for the Nairobi sections, like from Monday. So we'll start like making sure that everything is in place before February.
We'll get started. All right.
Yeah.
All right.
Well,
Okay.
thanks for
Guys, I'll be leaving now. I need
yeah. I mean, yeah. Thanks for hanging
Yeah.
around.
Thanks. Yeah. Thanks, Darlington. Yeah.
Yeah. Good night.
Yeah,
All
sure.
right, man.
Yeah.